Hi, I'm Riya Bensal, a data science trainee at Analytics Vidhya and an AWS certified solutions architect. I work on machine learning and generative AI to build real world data driven solutions. And in this course, I'm going to show you how to use AI to actually get the work done. What if you could hand off your most repetitive, time consuming work to an AI and actually trust it to get it done? Not just ask it a question, not just generate a draft, actually give it a task, walk away, and come back to a finished result. That is what Claude Cowork makes possible. And that is exactly what this course is going to teach you. Cowork is not a chatbot. It is a desktop AI that can plan, execute, and complete real multi-step work across your files, your apps, and your workflows without you writing a single line of code. You give it a goal in plain English, it figures out the steps, it gets it done. In this course, you will go from zero to building automated workflows that actually work in the real world. You will learn how to prompt Cowork the right way, connect it to the tools your team already uses, and build reusable skills that run consistently, whether it is you triggering them or your entire team. By the end of this course, AI won't just assist you. It will actually be doing meaningful work for you. Not someday, not theoretically. You will see it working. So let's get into it. Hello learners and welcome to the course. We are starting with a very exciting question. What exactly is Claude Cowork and why are tools like this becoming so important right now? We are entering a phase where AI is no longer limited to just answering questions or generating content. It is beginning to act more like a real work partner, something that can understand your intent, follow instructions, and help complete actual tasks. That is exactly what makes Claude Cowork interesting. It represents a shift from AI that only responds to AI that can actually support execution. In this video, we will understand what Claude Cowork is, where it fits in the larger Claude ecosystem, and what kind of value it brings to non-developers and teams. So let's begin by first understanding at a very basic level what Claude Cowork actually is. Let's start simple. Claude Cowork is an AI work assistant built for non-developers and teams. Its purpose is not just to chat with you, but to help you get actual work done through plain English instructions. So instead of learning code or setting up complex automations, you can simply describe what you want and Cowork helps execute it. That is what makes it feel less like a chatbot and more like a real digital coworker. Now, why do we even need something like Claude Cowork? Because most people do not just want AI to generate text. They want AI to help them complete tasks. But there is usually a gap. Chat tools can answer and suggest, while automation tools often expect technical setup or coding knowledge. Claude Cowork sits in the middle of that gap. It helps turn simple instructions into completed work, making automation much more accessible. To understand Claude Cowork well, it helps to see where it fits in the broader Claude ecosystem. Claude.ai is the general-purpose workspace for conversation, writing, research, and analysis. Claude API gives developers API access to integrate Claude into their own applications and workflows. While Claude Code is a terminal-first agentic coding tool for developers, built to work directly with code bases, files, and commands. Now, the important connection here is this. Claude Cowork uses the same agentic architecture that powers Claude Code, but makes that capability accessible inside Claude Desktop without requiring the terminal. In other words, Claude Cowork can be explained as a more approachable, no-code experience built on top of the same core execution style that made Claude Code powerful for developers. That is why Claude Cowork feels like execution-oriented AI rather than just a chat interface. This brings us to the core value proposition of Claude Cowork. It offers desktop-level AI automation without requiring you to write code. You can give it instructions in plain English and it can break that down into steps, execute those steps, and help you reach that final outcome. So this is not just about getting an answer. It is about getting the work done. This is the real shift here, from AI as a responder to AI as an executor. This is where Claude Cowork becomes especially powerful. A simple plain English prompt can lead to multiple actions. For example, you might ask it to find a report, summarize it, draft an email, and save the output as a document. That is not one action. That is a sequence of connected tasks. And Cowork can understand that larger intent and work through the steps. This is what makes it useful for real-world workflows, where work usually does not happen in just one move. What kind of work can Claude Cowork actually help with? Quite a wide range. It can support file-related tasks like organizing, renaming, summarizing, or extracting information. It can help with research by gathering information, comparing sources, and synthesizing findings. It can assist with communication by drafting emails, summarizing threads, or preparing updates. It can also support scheduling and coordination, and in many cases work across connected tools and systems. So, overall, Cowork is designed for practical day-to-day digital work. An important thing to remember is that Claude Cowork is designed to be approachable. It is especially useful for professionals who want AI support without needing coding skills. It is also usable for teams dealing with repetitive multi-step or cross-functional work. If your work involves documents, communication, research, coordination, or follow-up, Cowork can be highly relevant. So, while developers may also use parts of the Claude ecosystem, Claude Cowork is especially meaningful for non-developers and business teams. That was your introduction to Claude Cowork. The key idea to remember is that Claude Cowork is not just another AI chat interface. It is designed to help people and teams move from asking to actually doing. It sits within the broader Claude ecosystem as a no-code work execution layer, helping users automate real tasks through plain English instructions. Thank you for watching, and I'll see you in the next one. Hello learners, and welcome back. In the last video, we understood what Claude Cowork is. Now, the next important question is, how is it different from Claude.ai and Claude Code? Because all three are part of the same broader ecosystem, but they are built for very different kinds of work. So, in this video, we will compare them side by side and understand when each one makes the most sense to use. This comparison matters because many people assume these are just different versions of the same product. But that is not really true. They may all use Claude, but they solve different workflow needs. And if you choose the wrong one for the task, your workflow becomes less efficient and operationally misaligned. So, the goal here is simple: understand the right fit based on the task, the user, and the work environment. At a higher level, you can think of these as three different Claude experiences. Claude.ai is your general workspace for chat, writing, and research. Claude Code is built for developers working with code, files, and commands. And Claude Cowork is designed for no-code task execution across desktop and team workflows. So, the easiest way to remember this is one helps you think, one helps you build, and one helps you execute. Now, let's make the differences more concrete. Claude.ai is mostly conversational oriented. Claude Code is an action-oriented inside technical environments, and Cowork is action-oriented for desktop and team workflows. So while Claude.ai often helps you reason through a task, the other two move closer to execution. The big difference is where that execution happens, in code for Claude Code and in everyday work tools for Cowork. A very practical way to choose is by asking, what kind of task am I doing right now? If the task is about brainstorming, research, writing, or analysis, Claude.ai is usually the right fit. If the task is technical and lives inside a code base, Claude Code makes more sense. And if the task is multi-step, operational, and spread across files or apps, that is where Cowork becomes the stronger option. This is where Cowork becomes especially interesting. Claude.ai is great at helping you think, explore ideas, and draft outputs, but Cowork moves beyond that into execution. Claude Code also goes beyond chat, but in a very different setting. It is designed for developers working directly with code, files, and commands. So, Cowork sits in the middle as the bridge between conversational AI and real no-code desktop task execution. So, Cowork sits in the middle as a bridge between conversational AI and real no-code desktop task execution. That is why it feels less like a chatbot and more like a working partner. Let's look at a real example. Suppose the task is read the latest monthly sales report in your folder and summarize the top 5 insights for your manager. Claude.ai can absolutely help with the structure, wording, and reasoning of that summary. It can tell you how to frame the response and even help you draft it well. But Cowork can take that same request and treat it like an executable workflow. It can find the file, open it, read the report, extract the important points, and prepare the final summary. So the same prompt may sound similar, but the outcome is very different. Claude.ai helps you think through the task, while Cowork helps move the task toward completion. Now compare Claude Code and Cowork. Both are more action-oriented than a normal chat interface, but they operate in different environments. Claude Code is strongest when the workflow lives in code, scripts, files, commands, and development tasks. Cowork is strongest when the workflow lives in business tools, documents, communication, and coordination. So both are agentic, but context decides which one fits better. This slide gives you the decision guide to remember. If your day is mostly asking, exploring, drafting, and analyzing, Claude.ai is likely your default. If your day is mostly coding, debugging, testing, and modifying systems, Claude Code is the better match. And if your day involves processing files, coordinating work, and handling repetitive multiple tasks, Cowork is usually the strongest fit. So, the best product depends on what kind of work fills your day. Now that we have compared Cowork within the Claude ecosystem, let's briefly compare it with similar product outside it. Google Anti-Gravity is much more development-centered with agents working across the editor, terminal, and browser. Cowork, in contrast, is focused on no-code execution across desktop tasks and business workflows. So again, the core difference is not just the interface, but the environment where the work happens. The easiest way to choose between Google Anti-Gravity and Cowork is to ask, where does the work live and what kind of access is needed? If the work is mainly software development and requires code, commands, browser access, and verification, Anti-Gravity is the better fit. Cowork is better suited for business and operational workflows. It can work with local files and folders on your desktop, and it can also connect to tools like Gmail, Slack, and other platforms through connectors. So, in simple terms, anti-gravity is stronger for agentic development workflows, while Cowork is stronger for no-code execution across desktop and cross-tool business workflows. So, here is the key takeaway from this video. Claude AI helps you think, Claude Code helps developers build, and Cowork helps team execute. They are not competing versions of the same thing. They are different ways of working with AI. Once you understand that, choosing the right Claude experience becomes much simpler. So that was our comparison of Claude AI, Claude Code, and Cowork. The main idea is to remember is that Cowork stands out as a no-code execution layer for real desktop and team workflows. And the more clearly you understand the strengths of each product, the more effectively you can use them in the right context. Thank you for watching, and I'll see you in the next one. Hello and welcome back. In the previous video, we compared Cowork with Claude AI and Claude Code to understand where it fits in the ecosystem. Now, the next important question is, who is Cowork actually built for? Because not every AI tool is meant for every kind of user, and Cowork becomes most valuable when the work pattern is the right fit. At a high level, Cowork is built for people who do real digital work, not just chat with AI. It is especially useful for users dealing with repetitive, messy, or multi-step tasks across files, apps, and connected tools. And the good part is you do not need to know coding to use it, but you do need to know how to describe the task clearly. The best way to identify a good Cowork user is not just by job title, but by work pattern. If your work is repetitive, multi-step, file-heavy, coordination-heavy, or spread across tools, Cowork starts becoming very relevant. A simple test is this. If you often feel that a task repeats every week and still takes too long, that is usually a strong signal. Operation managers are one of the strongest fits for Cowork. Their work often involves recurring coordination, updates, file handling, and communication-heavy tasks. Things like weekly reports, inbox triage, follow-up summaries, and file cleanup may sound small individually, but together they take a lot of time. That is exactly the kind of workload Cowork can help reduce. Content creators and marketers may sit in different roles, but Cowork supports both in very practical ways. For content creators, it can reduce the overhead around research, asset organization, and even video workflows through plugins and connectors. So, it is not just helping with ideas, but also with the production of support around the content. For marketeers, Cowork is useful for campaign execution tasks that often repeat across tools, things like preparing briefs, drafting outreach, organizing reports, or automating parts of campaign workflows based on their needs. So, the value here is not only speed, but also smoother execution across content and marketing operations. Analysts and researchers, they are a strong fit for Cowork because their work is often document-heavy, synthesis-heavy, and repeated across similar formats. Cowork can help read files, compare reports, extract key insights, and prepare structured summaries more efficiently. But one more important advantage is the use of skills. Instead of writing the same instructions again and again to different LLMs for how a summary should be framed, analysts can use skills to standardize that output. That means the insights can be delivered more consistently and more accurately, and in the format different stakeholders actually need. So, Cowork is not just helping with the summarization, it is helping create repeatable, stakeholder-ready research workflows. This group often faces the same core challenge. Too many small but important tasks competing for attention. Scheduling, follow-ups, organizing documents, and drafting updates may not feel strategic, but they constantly consume time. Cowork can be especially helpful here because it gives these users a way to delegate operational work without needing an extra person. Cowork is strongest in a very specific zone. It beats manual work when the task is repetitive and taking too much time. It can be better than Zapier-style automation when the workflow is not fixed and needs judgment, synthesis, or file understanding. And compared to hiring a virtual assistant, it can be useful when the work is frequent, lightweight, and mostly digital. So Cowork works best in the gray zone between rigid automation and human delegation. One of the biggest advantages of Cowork is that you do not need coding skills to use it effectively. You do not need to build scripts, connect APIs, or set up technical automation just to get value out of it. But that does not mean no skill is required. The real skill here is giving clear and complete instructions. And that starts even before prompting well. First, you need to define goal clearly. Then you need to explain what exactly you are trying to achieve. provide the right context, mention any constraints, and make sure the output matches stakeholders' expectations. So, better you can frame the task, the better coworker can execute it. That is why better prompting does not just improve the answer, it improves the delegation itself. It is also important to understand what cowork is not. It is not a replacement for every human role, and it is not a magic tool for fully unsupervised complex work. It is also not a universal solution for every workflow. The right mindset is to see cowork as a strong execution assistant, not as a perfect autonomous worker for every scenario. So, who should use cowork? People and teams who deal with recurring digital work, operate across files and apps, and want no code execution support. If your work is messy but repeatable, cowork is likely a strong fit. But if you only want casual chat or expect fully hands-off autonomy for everything, then cowork may not be the best choice. The key is not just liking AI, it is having the kind of work that benefits from delegation. That was our answer to who should use cowork. The key takeaway is that cowork is most valuable for people doing repetitive, multi-step digital work that can be clearly delegated. When the work pattern is the right fit, cowork becomes much more than just a chat tool. It becomes a practical execution partner. Thank you for watching, and I'll see you in the next one. Hello and welcome back. In the previous video, we understood who should use cowork and where it creates the most value. Now, the next important step is to understand how cowork actually works behind the scenes. Because once you understand its mental model, it becomes much easier to use it effectively. In this video, we are going one level deeper into cowork's working logic. We will understand how it takes a goal, turns it into actions, uses files as a context, and moves through an agentic loop to get the work done. This is the mental model that helps you see cowork not just as a chat tool, but as an execution system. The simplest way to understand cowork is this. A task is the goal, and actions are the steps. You tell cowork what outcomes you want, and it figures out what needs to happen to get there. So, cowork is not only focused on the final answer, it is also focused on the path to that answer. This distinction is very important. The task stays at the goal, context, and outcome level. It defines what needs to be done, in what situation, and toward what final result. The actions sit at the execution level. What needs to happen next? Users usually describe the task in plain English, and cowork translates that into a set of actions it can actually perform. A key idea here is that cowork does not jump straight into action. It first understands the request, identifies what resources may be needed, and then sequences the work before execution begins. But even after planning the action sequence, cowork may pause and present that plan for user review. If the user gives the go-ahead, only then does execution begin. That planning step matters because most real tasks are not only solved in a single move. They need structure, the right order of steps, and sometimes a confirmation before moving forward. Let's make that more concrete with an example. A task may sound simple on the surface, but underneath it may require multiple actions. For example, reading a customer feedback file and summarizing the top issues means first finding the file, then reading it, identifying patterns, and finally drafting the summary. So one task can hide a full action sequence underneath it. This is where the agentic loop comes in. Cowork first plans the task, then thinks through the best way to approach it, and may also review the action sequence before moving ahead. After that, it acts, observes what happened, and adjusts if needed, and continues until the task is complete. That is what makes it feel more flexible than static automation. It is not just following a fixed path, it is reasoning, reviewing, and reacting as the task unfolds. The loop matters because real work is rarely perfectly linear. A file may not be where expected, the content may be different than assumed, or a better next step may become obvious only after the first action. So, cowork needs a way to stay goal-focused while still adapting to variation. That is exactly what the loop enables. Files are often a core part of cowork's working context. It may read files to understand inputs, extract information, or gather context. It may also write files to save outputs or update deliverables. So, files are not just passive inputs, they actively shape what cowork does next. A useful way to think about file context is through three questions. What does cowork read? What does it write? And what does it decide? It reads input like reports, notes, and documents. It writes outputs like summaries, drafts, and updated files. And in between, it makes decisions about what is relevant and what steps should come next. Another important part of the system is that cowork does not always act fully on its own. Sometimes it can continue automatically, and sometimes it pauses for confirmation. These checkpoints help balance speed with control. So the goal is not blind autonomy, but useful execution with the right level of oversight. A simplest way to understand this is, the more sensitive the action, the more likely cowork is to pause. If an action could affect important files or needs explicit approval, it makes sense to check first. But if the next step is routine and clearly aligned with the task, Cowork can usually proceed. That is what makes the system feel both efficient and reliable. So, that was our introduction to tasks, actions, files, and the agentic loop. The key takeaway is that Cowork is not just answering prompts, it is planning, acting, observing, and adjusting toward a goal. And that is what makes it feel agentic in a practical way. Thank you for watching, and I'll see you in the next one. Hello, and welcome back. Now that we understand how Cowork works, the next step is getting it set up correctly. In this video, we will walk through the installation process, the basic requirements, the permissions you need, and a quick first task to make sure everything is working properly. Before you begin, there are a few things you need in place. You need Claude Desktop on either Mac OS or Windows, an eligible paid Claude plan, and an active internet connection. It is also important to note that Claude Cowork does not work on the free plan. So, if you want to access Cowork, your account needs to be on a supported paid plan such as Pro, Max, Team, or Enterprise. And finally, Cowork works inside the desktop app, not as a web-only experience. So before anything else, make sure these basics are covered. The installation flow itself is straightforward. On macOS, download Claude Desktop, run the installer, and launch the app. On Windows, download or update Claude for Windows. Make sure you are on the latest version and then launch it. The key point here is simple. Always use the latest desktop version for the smoothest Cowork experience. So let's get into it. In this step, we'll walk through how to get Claude set up on your system. The process is slightly different depending on whether you are using Mac OS or Windows, but overall, it's pretty straightforward. This is the official download page, and you can see the link here. You'll see various options for Mac OS, Windows, and Windows ARM. Simply choose the version that matches your system and click on the download button. I'll go with the Mac OS. Once the package is downloaded, I'll select the version for my operating system. The installer file will start downloading. Over here, you can see the installer file. Once downloaded, open the file. Follow the installation prompts. It's a standard setup. After installation, launch Claude from Application folder on Mac and the Start menu on Windows. Then sign in with your account to begin. I have already downloaded and installed the app on my system. So instead of repeating those steps, I'll go ahead and open the app. Let me show you how the interface looks when you first launch it. This will give you a quick idea of what you will be working with. This is the Claude Desktop app. You can see the three modes here, the chat, cowork, and the code. The desktop app gives you quick access anytime and can connect to local files and tools, making it more powerful than just using it in a browser. In the upcoming videos, we will be performing many hands-on videos on this interface itself. So let's get back into it. In terms of requirements, the official setup guidance focuses on supported desktop platforms, internet access, the latest app version, and an eligible subscription. Instead of relying on a long public spec sheet, Anthropic provides a readiness check for macOS and for different Windows architectures. So the safest approach is to run that readiness check before setup and confirm that your system is ready. Once the app is installed, the next step is to sign in with your Claude account, which you can do by clicking on the settings option. Make sure that account is linked to an eligible paid plan. After that, switch from chat to cowork and enter task mode. That is the point where the experience moves from normal conversation into multi-step task execution. Permissions are a very important part of setup. Cowork may need file access to work with local folders and documents. And in some cases, it may also need app-level access depending on the task. You may also want notifications enabled so you can stay updated on the progress. The guiding principle is simple. Grant only the access that is actually needed for the workflow. Here, we will be performing a very simple first task that is the best way to verify that everything is working properly. For example, you can ask Cowork to list the top 50 files in your downloads folder. If that works correctly, it tells you that the app is running, your account is active, and the required file access is in place. So this is a quick and practical first test. So let's get into it. From here, I will select the folder that I want to give access to. Choose a folder, and then I'll select the downloads. Here you can see that the Cowork has prompted me to allow the access to that particular folder. So I'll choose the allow button. Then I'll give the prompt, list the top 5 files in this folder. You can also choose different kind of configuration settings. I'll go with the models on 4.6 and let's see. Here you can see the folder that I have given access to. Let's see the progress level. It is thinking like listing the files that are there. So you can see the results. So Yes, it is working properly. Now let's get back to it. During that first time, you should expect Cowork to show progress as it works. You may be able to review its approach, and in some cases, it may pause for approval before taking a more sensitive action, like the approval of the folder. So, Cowork is not working blindly in the background. It is designed to stay visible, reviewable, and permission aware as the task runs. So to recap, the setup flow is simple. Install the latest Claude desktop app, run the readiness check, sign in with an eligible account, open the Cowork tab, grant the required permissions, and verify everything with the first task. One final point to remember is that the desktop app needs to stay open and your computer needs to stay awake while Cowork is actively working. Once that is in place, you are ready to start using Cowork properly. So, that was the installation and setup walkthrough for Cowork. The key takeaway is that getting started is simple, but the right setup matters. From correct desktop version to the right permissions and a quick verification task. Once everything is configured properly, you are ready to start handing real work to Cowork. Thank you for watching, and I'll see you in the next one. Hello and welcome back. Before we start throwing real tasks at Cowork, let's take a proper tour of the interface. Because knowing where things are and what they mean will save you a lot of confusion later. We are going to walk through every panel, and more importantly, we are going to understand each one through live examples, not just theory. Let's open Claude Desktop and get into it. The first thing to notice is right at the top center of the Claude Desktop app, a mode selector with three options: Chat, Cowork, and Code. This is how Claude Desktop switch personalities essentially. Chat is the familiar conversational Claude you already know, great for quick questions, writing help, and brainstorming. Now let's switch the mode and look at Code. Code is basically the Claude Code, a powerful agentic coding environment for developers. Here you can edit the code as well. Code is the Claude Code, a powerful agentic coding environment for the developers. Here you can open your directories and start coding with small edits as well. Now let's switch the mode to Cowork. It is basically what we are focused on. It is the middle ground built for knowledge work. Think document creation, file organization, research synthesis, anything that involves your local files and multi-step execution. You can see right now we are on the Cowork tab. The interface has shifted. The heading says, let's knock something off your list, and instead of a chat thread, you are looking at a task workspace. This distinction matters. You are not having a conversation here, you are assigning work. Now, let's go through each part of the interface systematically. The task input bar. Notice it sits right in the center of the screen. When you have no active session with the placeholder text, how can I help you today? Once a task is running, this bar moves to the bottom of the active task view and becomes how you send mid-task instructions to Claude. Think of it like a brief you hand to a colleague. Instead of typing, can you help me with my files? You would type something like, go through my downloads folder, group all the PDFs by year based on their file name. Or you could say metadata as well. And add one more task and create a summary. Since I have lots of data in my downloads folder, let's take the first top 5. That's the level of certainty that makes Cowork shine. Also notice two things inside this input bar. There is a work in project dropdown with a plus button. This lets you attach this task to a project, which we will cover separately. On the right, you can see the model selector, currently showing Sonnet 4.6. According to your preferences, you can go with some other model as well. Then on the left sidebar, this is your navigation hub. At the top, you have new tasks to start fresh. Below that, search. It basically lets you find past sessions. This is where you manage recurring tasks you have set up with the schedule command. Let's look at the left sidebar. This is your navigation hub. On the top, we have new tasks. This is where you start fresh. Below that, we have search option. It basically lets you find the past sessions, or basically the chat history. Then we have scheduled. This is where you manage recurring tasks you have set up with the /schedule command. Then the project. The projects tab help us basically groups related tasks into persistent workspaces. Then we have ideas. On the interface, you can see that we have various built-in tasks that have been provided by the Claude itself. This is where Claude can help you brainstorm tasks to run, like write a blog post, build a web app, or automate a browser task. You can start your own as well, like by going to Create button or Analyze. These are the various categories that Claude offers. Now let's go back. Below those navigation items, you'll see a recent section. Right now it says no sessions yet because this is a fresh install. After you run a few tasks, your history will populate here. and you can click any past session to review exactly what Claude did step by step. Then you can go to the settings icon by clicking on the profile, by clicking your name and avatar at the very bottom left. You'll see your name, so click on that, then you can choose the settings option. Inside settings, Cowork is where you'll configure the global instructions, folder permissions, and more. We'll visit this in the productivity tips section. Right now, you can see the account, usage, and the capabilities. We have connectors as well. We'll cover this in a separate section. You'll see the Cowork. Here, you can edit the global instructions for your workspace. Then we have extensions as well. You can browse the extension that Claude Cowork offers. So let's try using them. Go back and click on the new task. Let's see. Let's pick a task that Claude is offering, organize my screenshots. When I clicked on organize my screenshots, Claude offered me a built-in prompt. You can make some specific changes if you want, or just experiment with the existing one. We have other built-in tasks as well, like optimize my week, organize my screenshots, and find insights in the files. These are not just decorative. You can actually click any of them to kick off that type of task immediately. And at the bottom, there is customize with plugins. Which lets you add specialized capabilities to Cowork. You can choose any of them to experiment with. In the further videos, we will be experimenting with various plugins to perform some hands-on tasks. Now, let's try performing this action, but I'll make some changes to the prompt. I'll select the desktop folder. I'll give the access. You can't really understand it by looking at an empty interface. So let's actually give something. Here's the thing about the action log. You can't really understand it by looking at an empty interface. So this is what we have asked Cowork to do. I have given a small task. Watch what happens on the right side of the screen. The action log panel has appeared and it's already populating with the screenshots that I have in my desktop folder. Over here, it has divided the task into 4 subtasks. The first few lines are planning entries. Claude is analyzing the request and deciding how to approach it, which you can see in the progress section. You might see something like analyzing task structure or determining the file access approach. This is Claude's prep work before any real action begins. It's like watching someone read a recipe before starting cooking. So over here, you can see that it is reading the files. All the files that are there in my desktop folders. Next come execution entries. These are the action lines. You'll see Claude reading from your desktop directory, cataloging file extensions, counting the occurrences. Like over here, you can see the total images on desktop is 61. Each line tells you specifically what Claude touched. This is critical. If you ever see Claude reading from a folder you did not expect, say your documents folder when you only mentioned desktop, that's the moment to pause and ask why. Over here, we can see that it has performed the task and it has grouped all the files in different sections, like a group sort of things. If the tasks were more complex, say reorganizing hundreds of files, you would also see sub-agent entries. That's Cowork spinning up parallel work streams, like having multiple assistants working simultaneously on different parts of the job. The log would show concurrent threads of activity and it might look chaotic at first, but it's intentional and efficient. Finally, a completion marker appears, usually a summary line telling you the task is done and what was produced. Over here, we can see that it has produced 37 files with 11 folders and 36 renamed files with 1 suggested deletion. The habit to build here, don't just let the action log scroll past. Give it a glance every 30 seconds or so during a running task. If everything looks consistent with what you asked for, great. Let it run. If something looks off, that's your cue to intervene. As you use Cowork more, you'll manage multiple tasks across different points in time. The interface reflects 3 states a task can be in. When you submit a task, but Claude hasn't started it yet. Perhaps because another is running, or you have scheduled it for later. It lives in the queue. Think of it as a waiting room. Active task view is what you see while Claude is working. This is where the action log is live. And where the pause and cancel control appears. There is only ever one task running at a time in a standalone session. Now, the control that gives you real power over a running task. Whenever you run a task, like say, I'll say run it again. Once it starts running, you'll see the pause option over here. Pausing is your first and gentlest option. When you hit pause, Claude finishes the individual step it is currently executing. It won't cut off mid-file write and then stops and waits. Like I'll see, hit pause, add that clarification in the task input bar, then resume. Claude incorporates your new instruction and continues. This pause, add context like resume loop is one of the most useful pattern in Cowork. Then we have cancelling option also. Cancelling is the full stop. Use this when the task has gone in a fundamentally wrong direction and you would rather start over with a better brief. You have the option to rewrite as well, or basically restart the conversation from here. This is also a good moment to mention deletion protection. Cowork has a built-in safeguard. If any step in Claude's plan requires permanently deleting a file, it will pause automatically and show you a confirmation prompt asking for explicit permission. Like over here, I'll experiment with this command. Cut. Like over here, I will experiment with this command. It says that it is working on it, listing all the folders on the desktop that was curated separately. Always read that prompt carefully before clicking the allow button. Now, it has asked that there are pre-existing folders. You can either prompt the model to choose a particular folder or just choose all of them. You now have a complete mental map of the Cowork interface, the three modes at the top, the task input bar, and how to write the prompt, the sidebar navigation, where to find settings, and how to read the action log as your real-time window into Claude's work. How to read the action log as your real-time window into Claude's work, and how to stay control with pause, resume, and cancel. In the next video, we are putting all of this into practice. We'll run your first real multi-step task, something meaty enough that you will actually see sub-agents in action and have a chance to do a mid-task pause and redirect. Thank you for watching and I'll see you in the next one. Hello and welcome back. In this video, we are focusing on one of the most important setup decisions in Cowork, file and folder permissions. Because once Cowork starts working with real files on your system, the question is not just what it can do, but also what it should be allowed to access. So let's understand how to set safe boundaries before we let it do real work. Think of this as defining Cowork's working boundary. What folders can it read from, where can it write outputs, and what should stay completely out of scope. If you get this part right clearly, Cowork becomes much safer and much easier to trust in daily workflows. At a basic level, Cowork only needs access to the files and folders relevant to the task. It may read files to gather input or context, and it may write files to save summaries, drafts, or updated outputs. So, a good permission model is not about giving maximum access. It is about giving just enough access for the work that needs to be done. A simple way to think about permissions is in two stages. In a safer, more controlled setup, you keep Cowork inside a narrow workspace for testing and experimentation. In a broader production setup, it may work with real files, real outputs, and in some cases, even connected tools or apps. So, the question to ask yourself is, am I still experimenting or am I ready for real production work? One of the best habits you can build is creating a dedicated workspace folder, something like /Cowork project. This gives Cowork one clear place to work in, and it gives you one clear place to review what it creates. Instead of letting files spread across your system, you create a safe zone for drafts, reports, experiments, and outputs. That makes the whole workflow cleaner right from the beginning. Now, let's think about what should go inside that workspace. Good candidates are project files, research folders, working drafts, non-sensitive reports, and output folders. In other words, things that support the current workflow without exposing unnecessary risk. A useful rule here is simple. Allow only what the current task actually needs. And just as important as what you allow is what you block. Sensitive folders like finance records, legal files, HR data, personal archives, or anything containing credentials, API keys, or confidential data should stay out of scope. A helpful mindset is this. If a folder would make you uncomfortable sharing with an assistant, it probably should not be shared with Cowork either. So, permission design is not only about convenience, it is also about judgment. Now, here is the interesting part. Cowork's decisions are shaped by the boundaries you set. If only a small set of folders is available, it will make read and write decisions within that scope. That is exactly what we want. Narrow boundaries lead to safer behavior, clear execution, and easier review. So, in many ways, good permissions are not just a safety control. They are also a way to improve focus. Of course, your setup does not need to stay fixed forever. A good approach is to start narrow, validate the workflow, and then expand access gradually as your use cases grow. Maybe you begin with one project folders, then later add research folders, output folders, or trusted connected tools. The key is to expand intentionally, not all at once. So, if we bring it all together, the best strategy is simple. Start with one dedicated workspace folder, keep sensitive directories out of scope, use Cowork first on straightforward read and write tasks, then only after the workflow proves itself, expand access to more folders or trusted tools. That way, you get the benefits of Cowork without creating unnecessary risk from day one. So, that was our guide to settling file and folder permissions in Cowork. The key takeaway is that permissions define cowork's working boundary, and the clearer that boundary is, the safer and more reliable the workflow becomes. Start small, stay intentional, and expand only when the workflow truly needs it. Thank you for watching, and I'll see you in the next one. Hello, and welcome back. Now that we have understood how to set up Cowork up safely, the next practical question is which plan actually fits your workflow? Because once Cowork becomes part of real work, pricing, usage limits, and team features start to matter a lot more. So, in this video, let's break that down in a simple and practical way. Let's start with the big picture. In this video, we are not just looking at prices. We are looking at what each plan actually means for the way you work. Which plans include cowork? What do usage limits look like in practice? When does an upgrade make sense? And what changes once teams get involved? Those are the 4 questions we are going to answer. The first thing to know is very simple. Cowork is not available on the free plan. So, if someone is using free, they can still access Claude Chat, but not Cowork itself. Cowork becomes available only once you move into the paid plans, Pro, Max, Team, or Enterprise. So, a useful way to think about it is free is for basic chat, and paid plans are where Cowork begins. Now, let's quickly look at the pricing structure. Pro is the starting plan for individual Cowork use, Max is for much heavier individual usage, and Team plans are priced per seat for collaborative rollout. Enterprise sits in a separate category with custom pricing. So, even at a glance, you can see that Cowork is positioned as a serious productivity feature, not as a casual free add-on. But pricing alone is not the real decision maker. What matters more is how the plans progress and what each one actually enables. For individual users, Pro is the starting point for Cowork, while Max builds on Pro with much higher usage capacity, higher output limits, and priority access. Then separately, you have the organization-focused plan, Team and Enterprises. And one important detail to remember is that usage is shared across Claude surfaces. So Cowork does not sit in a completely separate usage bucket by itself. You can monitor this in settings where usage is there. Claude shows progress for both your current session and your weekly usage. Along with usage limits, there is another concept learners need to understand: length limits. These are tied to Claude's context window, which is basically the amount of information Claude can work with in a single conversation at one time. You can think of it as Claude's working memory. For standard plans, the context window is 200k tokens. On Enterprise, some models support a 500k token context window. So, when conversations become very long, or when you add large files and detailed instructions, you are using up space inside that working memory. When conversations get long, Claude can automatically manage context and supported workflows by summarizing earlier parts of the conversation, so the interaction can continue more smoothly. Even when that happens, the full chat history is still preserved. In practice, this means longer and more natural conversations with fewer interruptions, although rare edge cases can still hit context limits. There are also a few ways to use your context windows more efficiently. The most important one is using projects, because projects use retrieval augmented generation (RAG), which helps Claude work with larger knowledge bases more efficiently. It also helps to keep project instructions short, remove files you are no longer using, turn off extended thinking when it is not needed, and disable non-critical tools or connectors for conversations that do not require them. Here is an important clarification. Public sources clearly tell us which plans include Cowork, what the pricing looks like, and how user monitoring works. But they do not give a neat public table for Cowork-specific limits like exact task caps, concurrent tasks, file size caps, or connector quotas by plan. So the right mindset here is be precise about what is officially known and avoid assuming hard limits that are not clearly published. So, when does it make sense to move up a plan? A good signal is when Cowork stops being something you try occasionally and starts becoming part of your real workflow. If you are hitting limits often, tasks are getting interrupted, or multiple people now need shared usage and more structure. That is usually the point where an upgrade starts making practical sense. So, upgrades are less about curiosity and more about workflow maturity. Now, let's look at the organization side of the story. Team is built for collaborative rollout. It adds shared workflows, central billing, and administration, single sign-on, domain verification, connector controls, enterprise desktop deployment, and organization-wide search capabilities. So Team is really about helping multiple users work together in a more managed environment. It adds spend controls, fine-grained role-based access, SCIM provisioning, audit logs, compliance API, custom data retention controls, network-level controls like IP allow listing, and other enterprise-grade security capabilities. So, in simple terms, Team is for managed collaboration, while Enterprise is for governed scale, security, and compliance. So that was our overview of cowork plans, pricing, and usage limits. The main takeaway is that the right plan depends on how deeply cowork is part of your workflow, whether you are using it individually, collaboratively, or at an organization scale. Start with the plan that fits your current usage and upgrade when your workflow genuinely grows beyond it. Thank you for watching, and I'll see you in the next one. Hello and welcome back. In today's video, we will focus on one of the most essential skills of using cowork effectively: writing strong task prompts. You see, cowork is not just generating text, it is executing work. So, the way you write your prompts directly influences how well the task gets done. By the end of this video, you will know how to design prompts that cowork can reliably execute, and you will move from vague instructions to structured workflows. So, why does prompt quality matter? Well, cowork turns your prompts into actions. If your prompt is vague, it leads to unclear or inconsistent execution. However, when you create a structured prompt, you get predictable results. Better prompts is equal to fewer iterations. Simply put, prompt quality is equal to execution quality. A well-designed prompt is the foundation for effective task execution, and the clearer the instructions, the better the result. A strong prompt is made up of four key components: context, action, output, and constraints. Context is what the task is about, the situation or the background. Action tells cowork what needs to be done. Output specifies the expected result or deliverables. Constraints define the limits or rules for the task, like time, scope, or format. By breaking your prompt into these parts, cowork will know exactly what to do and how to do it. Let's look at an example. A vague prompt might be summarize this report. This leaves a lot open to interpretation. What does summarize mean? What kind of output is needed? What if we improve the prompt by open a specific file, extract the top 5 insights, write in bullet format, and save with a specific name in the specific format? Now, it's clear. The task, the file path, the steps, the output format, and the save location are all defined. The cowork can execute this reliably. Alright, let's look at some real-world examples where we take vague prompts and turn them into specific executable instructions for cowork. For instance, the vague instruction would be clean this data, but the specific one, open this file, remove any rows with missing values, standardize the date format, and save it as cleansales.csv in the outputs folder. See the difference? The more details you provide, the clearer cowork's job becomes. On the screen, you can see many more examples like that. Like the vague instruction would be prepare the report, but the specific one would be open the specific file, extract key metrics, create a summary with sections like overview, insights, and recommendations, and save it as q3report.txt. See the pattern here? Specific prompts give cowork all the information it needs to get the job done exactly the way you want. Once you have defined the context, the next step is to get into the details, files, and outputs. You will want to make sure that cowork knows exactly where to find your files, where to save the output, and what format the result should be in. Specifying the file path clearly means cowork won't have to guess where the file is located. Similarly, by stating the output file name, format, and destination folder, you are giving cowork all the information it needs to execute the task accurately and efficiently. Before diving into file paths, outputs, or constraints, let's first talk about context. When you write the prompt, the task context is the most crucial element. It defines what you want to achieve and why it matters. Without this context, the rest of the prompt, the specific actions, file paths, or output, doesn't have much meaning. Context ensures cowork knows the big picture and can properly translate your intent into actionable steps. Think of it as the foundation for the rest of your task. Once the context is clear, everything else falls into place more smoothly. Now, let's talk about constraints and edge cases. These are game changers when it comes to making sure cowork does exactly what you need, even in tricky situations. So, what does that look like? First is limit the scope. If you only need the top 5 rows of data, say that upfront. No need for cowork to waste time with unnecessary info. For example, give me the top 5 insights from this file. Define the exclusions. Maybe you want the cowork to ignore empty rows in a dataset. A simple constraint like skip rows that have no data helps narrows the focus. Third is handle edge cases. What happens if cowork can't locate the file? Instead of leaving the process hanging, you can say, if the file does not exist, create a new one. Now, cowork knows exactly how to proceed, no matter the situation. Fourth and the last one is validation. You can also ask cowork to check if the results meet your expectation. For example, ensure the output is clean and readable. This adds an extra layer of assurance that your final deliverable is up to the mark. These constraints guide Cowork's behavior and help it handle the unexpected. And by including edge cases, you make sure Cowork does not just blindly run through the task. It is flexible and adaptive. The more detailed your constraints, the less room there is for errors or surprises. Another important concept is multi-condition prompting. With this, you can use conditional logic in your prompt. For example, if X is the case, then do Y, otherwise do Z. An example might be if the file exists, update the content. If it does not, create a new report from scratch. This allows Cowork to adapt based on the situation and make your workflows more flexible. Let's start with a very common example. For that, we need to go into the Claude code. So let's open our Claude app. Now, at first glance, this sounds fine, but think about it. What does analyze even mean here? Are we calculating revenue? Are we finding trends? Are we summarizing? Or basically cleaning the data first? The AI has no clear direction. This is exactly why vague prompts lead to poor results. AI tools like Cowork don't interpret intent the way humans do. They execute instructions. And when instructions are unclear, the output becomes inconsistent, incomplete, or just not useful. So you end up doing multiple back and forth iterations, which wastes time. So instead of vague prompts, we use a structured format. Every strong prompt has 4 parts: context, action, output, and constraints, like we talked about in our previous slides. Think of this like giving a clear brief to a junior analyst. Now let's take the same task and rewrite it properly. Here would be the improved version. Now, notice what changed here. On my screen, you can see the prompt that I wrote. We did not change the task, we just made it more clearer. The context tells the AI why we are doing this. The action gives step-by-step instructions. The output defines how results should look. And constraints prevent messy or irrelevant results. This is why structured prompts lead to predictable, high-quality outputs. If you remember just one thing from this session, remember this. Prompt quality directly determines execution quality. Better prompts don't just improve results, they reduce the number of retries you need. Let's take another quick example. If I say, clean this dataset. Firstly, I'm not specifying the dataset or basically which file I want the dataset to be clean. So, what does cleaning mean? Remove nulls, fix formats, handle duplicates. Again, it's unclear. So, instead we write it like this. Open the customer dataset, remove duplicate rows, fill missing age values with the median, standardize the data format, and save the clean file. Now, this is something the AI can execute reliably without guessing. This applies beyond data tasks too. For example, if I say write an email update, that is vague again. Now, the improved version would be draft an email to my manager, summarize project progress, highlight 3 key achievements, mention one blocker, use the formal tone, and present it in bullet points. Now, the output will be structured, professional, and ready to send. One of the most underrated parts of prompting is constraints. This is where you control edge cases. For example, what if the file has missing values? What if the dataset is too large? What if something fails? You can handle all of that inside the prompt. Now, let's go one step further. This is where prompting becomes really powerful. You can actually add logic like, if the file exists, perform the analysis. Else, create a sample dataset and then analyze. Over here, you can specify the file name, Q3 sales.csv. This turns your prompt into a mini workflow. Over here, we'll select the folder. Let's run the test. This turns your prompt into a mini workflow. Now, the AI is not just executing, it is making decisions based on the condition. Since the file does not exist in my destination folder, it will try to create the sample dataset and then analyze. Over here on my screen, you can see that it has displayed that the specific file does not exist in my folder. So it is creating the sample dataset and running a full analysis. You can see the progress in this sidebar. Let's make this interactive. Think of a prompt you can pause for the effect by going here. Now ask yourself, did I give clear actions? Did I define the output? Did I add constraints? Most of the time, the answer is no. So make sure you do all of that. Over here, you can see Since I prompted the conditional statement that if the file did not exist, I asked it to create a sample dataset. You can see the response. It not only created the sample dataset, but did the analysis as well. After the analysis, it created the sales performance dashboard as well. You can see how detailed the responses would be if you prompt the model in a right way. To wrap this up, the difference between someone who struggles with AI and someone who gets powerful results is not the tool, it is how they write prompts. Once you start thinking in terms of context plus action plus output plus constraints, you move from trial and error to predictable execution. And that's when AI actually becomes useful. Better prompts don't just waste time, they unlock the full potential of AI. Now, let's summarize the key takeaways. Strong prompts follow a clear structure: context, action, outputs, and constraints. You have to be explicit about files, outputs, and restrictions. Avoid ambiguity by being specific. Iterate and refine your prompts for better execution. Remember, better prompts is always equal to better execution. The better you design your task, the better Cowork can perform it. Thanks for watching, and I'll see you in the next one. Hello and welcome back. In this video, we are diving into how Cowork handles various file types and tasks like reading, writing, renaming, and organizing. Whether it's PDFs, Word docs, Excel sheets, or even image-based files, Cowork can help automate file management in powerful ways. Let's see how it works. Cowork can read a wide range of file types, including PDFs, Word docs, Excel sheets, CSVs, TXT files, and even OCR for image-based files. Once Cowork identifies the file type, it follows a clear process. First is context injection. It understands the task and file context. Second is tokenization. Breaks the task into manageable chunks. Third is tool-based access. Uses the right tool for each file type. Fourth and the last one, it processes the data based on your task. This ensures accurate data extraction and efficient task execution. Once Cowork recognizes the file type, it starts with context injection, understanding what the task is about and what needs to be done. After that, Cowork tokenizes the content, breaking it down into manageable parts. Next, it uses the appropriate tools to extract data from the specific file format, whether it's CSV, PDF, Word, and etc. Finally, Cowork applies reasoning to process and organize the extracted data in line with your task requirements. You can also create new files with Cowork. For example, you can generate a Word document, save as CSV file, or write a Markdown report. Just be sure to specify the output format and file name so Cowork can create them exactly the way you need. Cowork can also bulk rename files using custom naming conventions. For example, you rename all your files to match the pattern. You can see one of the pattern names that you can use in the slide. This is perfect for organizing files consistently by date, project, or file type. Once your files are renamed, Cowork can automatically organize them into subfolders, saving you time and effort. Here is just one example of how it works. You can set rules to move files by date, file type, or even keywords in the file name. For example, if you're working with financial reports, Cowork can automatically move files that contain the word finance into a folder labeled by keyword or the finance. Similarly, if you want to organize everything by date, Cowork can group files like 2023 followed by 07, that is the month name followed by the date, into a subfolder for that date. This is just one of the ways Cowork keeps everything neat and structured. The important takeaway is that Cowork helps you manage your files without having to manually move them, keeping your system organized in a way that makes sense for your needs. Cowork can handle some tricky scenarios too. If there is a file conflict, for example, if a file already exists, you can set up rules to either skip or overwrite it. If you are working with read-only files, Cowork can handle access restrictions. Also, it can automatically clean up special characters in file names to avoid issues during file operations. Let's take a more realistic scenario. Imagine you have just completed a marketing campaign, and now you have multiple files: a CSV file with campaign data, a PDF report, and some notes in a text file. And your goal is to basically extract the insights, generate a summary report, and organize everything properly, all in one go. So, instead of doing this manually, we will give Cowork a single structured task that handles everything end to end. I'll give the prompt to the Cowork. Here goes the prompt that I'm writing in the input field. So I have written that open this particular folder and calculate the conversion rate for each channel. In my CSV, we have different channels like Facebook, Instagram, and LinkedIn. Now, after that, open the txt file which has some summary notes and extract the key points. And then create a report combining the insights from both the files and write the summary in bullet points. At the last, include the conclusion paragraph as well. Then save that particular report in that particular folder. After that, you have to organize the files as well. Move all the source files that I have given previously into the archive folder, and then keep the final report in the reports folder. You also have to handle the edge cases. If the report already exists, overwrite it. If any file is missing, skip and continue. Now, this is not just file handling anymore. We are combining data analysis, content extraction, file creation, and file organization all inside a single workflow. Over here, we can see the task progress for longer tasks and the instruction that Claude.md has. First, it will be reading the CSV file and calculating the performance metrics. You can see the progress report it has created over here. It is locating the source files, then calculating the conversion rates and identifying the top 3 channels from CSV, then extracting the key points from the txt file. All the steps it is following in a perfect manner that we put in the input field as our prompt. According to the priority task it created, we can see that first it reads the CSV file and calculates the performance metrics. Then it opens the notes file and extracts important context. After that, it combines everything into a structured report. And finally, it would organize all the files, moving raw data into an archive and keeping only the final output into the reports folder. Over here, we can see that it could not find the correct folder. So let's try pausing the task. So since it could not find the correct folder, let's try creating a new task by giving it access to the correct folder. I'll go to my desktop. Then this is the campaign data folder that we have. We have to select that one. We have to select that one and then paste our prompt. Now we can see it found the correct files that we needed to perform the analysis. In the scratchpad section, we can see that it viewed all the files that were there in the folder. So let's look at the result it provided. It says that both the source files were missing from the campaign data folder. And in my prompt, I mentioned that if any file was missing, then skip that part and continue. So it applied that edge case properly and continued to the next task. So it found the report that already existed and decided to overwrite it according to our instructions. It says that all the steps have been completed. Both the CSV and txt file were missing. So per the edge case rule, both were skipped. In step 2, it read the MD file that already existed in reports and decided to overwrite it. It includes a run log documenting each file's status, the prior Q3 analysis for continuity, and a conclusion explaining why no new analysis ran. And then it organized the files into a proper structure that were defined by us in the prompt itself. So let's look at the campaign summary it created. You can see the top 3 performing channels that we asked for. And after that, we also asked for a concluding summary at the last. It also included that as well. Now, you can see since both the files were missing, it decided to skip that part and continue to our analysis. But what if those files were there in the folder? Then what would the results? So let's try looking at that. I have added the files in the destination folder that was campaign data. Now let's prompt the model. I'll say I have added the missing files to do the proper analysis as asked previously. Let's look at the results, or basically the task priority it creates. Let's close this one for now. It was able to read all those files that I added. Now it is analyzing all the numbers, or basically all the numbers that are there in those files, and writing the report. This is exactly the kind of task you do after every project. Analyze results, summarize findings, clean up files. Normally, this takes multiple tools and steps. Here, it was just one prompt. Now, since we added all those missing files, it was able to do the proper analysis, and it provided us with the results as well, which it shows that the top 3 channels were email, LinkedIn, and Google Ads. The key finding was email and LinkedIn are the most efficient channels by conversion rate, while Google Ads dominate in raw volume. Instagram is the weakest performer and highest cost per conversion at $1,500. With the top channels, it gave us the conversion rate and the cost per conversion as well. So you can see how it gave us all the results in the proper format that we defined earlier in our prompt. Let's make this even smarter. I'll just add, if the conversion rate of any channel is below 4%, mention it under areas of improvement in the report. On the basis of the analysis that it created, we can see that the Facebook and Instagram are below 4%. So accordingly, it should add areas of improvement for those channels. Now, Cowork is not just executing, it is making decisions based on the data. That is, two channels fall below the 4% threshold, that is Facebook 3.16% and Instagram with 2.30%. It added that section now. This is where basic automation becomes intelligent analysis. Think about your last project. How much time did you spend analyzing data, writing summaries, organizing files? This is exactly what you can automate. So, the key takeaway from this demo is you don't have to think in isolated tasks like read a file or write a report. You can design a complete workflow, input, process, output, and then organize, all in one prompt. This is where AI stops being a tool and starts becoming a workflow engine. So, from here we can see that Cowork is the powerful tool for handling your files. Whether it's reading, writing, renaming, or organizing, Cowork can streamline these processes and save you time. By setting clear file paths, names, and formats, you make sure Cowork performs the task as expected without the surprises. Thanks for watching, and I'll see you in the next one. Hello, and welcome back. In the last video, we saw how Cowork can work directly with files, reading content, creating new files, renaming them in bulk, and organizing them into structured folders. That gave us a clear sense of how Cowork handles file-level operations in a practical workflow. Now, we take the next step. In this video, we will dive into multi-step tasks, the foundation of building more complex workflows where multiple actions are chained together to complete a larger goal. Let's dive into multi-step tasks, the foundation of building more complex workflows. Rather than tackling everything at once, Cowork breaks down a complex goal into smaller, ordered actions. This approach brings two major benefits. First, it helps automate repetitive multi-step work without you having to manage each step manually. Second, it improves precision because the task is executed in a clear sequence rather than as one vague instruction. So, instead of trying to do everything at once, Cowork moves step by step, and that makes the workflow both more reliable and easier to control. Let's first talk about how these workflows are structured, including the constraints and conditions that guide each step. Once we understand that, we'll see it in action through a hands-on example. Now, imagine you want to process a dataset. The workflow would look like this. Extract data from a CSV, clean it, calculate summaries, format it into Excel, and finally, save it with a timestamp. Each of these steps is a part of larger chain workflow, where one action leads to the next. And the key idea here is that Cowork handles these transitions seamlessly, following the sequence you define. Cowork can also handle conditional steps. For example, if a sheet has more than 100 rows, Cowork can automatically split it into chunks. You can define the condition and Cowork can decide the best course of action, adapting as needed. Before Cowork starts executing, it is important to review the action sequence. This steps allows you to ensure that everything is in order. You can check for any missing details or inconsistencies before moving forward, giving you confidence that the workflow will run smoothly. Sometimes things don't go as planned, and that's okay. Cowork lets you pause the task if needed, edit the plan, and then continue from where you left off, like we did in our previous video. This gives you flexibility to adjust workflows mid-task without starting over, making it easier to recover from any interruptions. In this hands-on, we are not just doing a task, we are building a workflow pipeline. The goal is to take the raw data and move it through multiple stages, extract, clean, analyze, format, and then save, exactly like a real production system. Imagine you have a CSV file with raw customer feedback. This data is messy. I'll show you the data that we will be using for this hands-on. Imagine you have a CSV file with raw customer feedback. This data is messy, inconsistent text, missing values, and unstructured comments. And your goal is to convert this into structured insights. Now, we'll do that using the Claude Cowork. So, let's go to the Claude app where we will prompt the Claude Cowork model. Over here, first, I will select the project folder. Desktop, I'll choose the M3V31. This contains my CSV file. Then, I will prompt the model. Step 1 would be the extract process. Open this particular CSV file, then extract the columns, review text and rating. Then the second step is clean. Remove the empty reviews, standardize the text, lowercase and remove symbols. The third step is analyze. Classify reviews as positive, negative or neutral. Calculate the average rating. The step 4 is conditional step. If the dataset has more than 100 rows, split it into chunks and process separately, or else process normally. Our CSV data contains around 160 rows, so technically this step should follow instead of processing it normally. Step 5 is format the output. Create a structured table where the review, sentiment, and rating columns would be there. Then at last, save it as the output feedback analysis file. Also, I have asked it to timestamp the file name. This is a perfect example of chaining actions. Each step depends on the previous one. If extraction fails, nothing works. If cleaning is skipped, analysis becomes inaccurate. If formatting is unclear, output becomes unusable. So, order is not optional, it's critical. So, let's see what kind of results it provides. Now, notice this step 4. We added a condition. If the dataset is large, split it, else process it directly. This is exactly how real systems handle scalability. You can see the to-do list it has created. First, it explodes the file, then clean the data, and then analyze it. After that, it creates a structured output with summary. And also, I asked it to timestamp the file, so it does that as well. Before running this workflow, we should always review the sequence it creates in the progress section. Ask, are steps in correct order? Is anything missing? Are conditions clearly defined? Because once executed, everything follows this chain. You can see on my screen that it has detected the 160 rows, triggering the chunk processing path. That is our fourth step. After that, it will classify the sentiment across chunks. Let's walk through what happens. First, the file is read and required columns are extracted from the CSV file. Then, the data is cleaned to remove noise. Next, sentiment analysis is applied. Then, based on the dataset size, it either splits or continues. Finally, everything is formatted into a structured Excel report that we can see over here and saved with a timestamp. You can see the timestamp over here. You can see how many positive reviews are there, neutral, and the negative one as well. It has also color coded the sentiment according to the review. So that's a great part from the Cowork's perspective. Now let's look at the summary. And you can see the analysis over here. The total reviews processed are 160. Then the average rating is 3.11 out of 5. Highest rating would be 5 and the lowest with 1. You can see the positive count, negative, and the neutral. With the processing method chunked. Since our CSV had like 160 rows, so it divided that into two chunks with one chunk size of 80 rows. And you can see the date and the timestamp. Now suppose during execution you realize something is wrong. Maybe sentiment classification needs adjustment. You don't need to restart everything. You can pause the workflow, edit the step, and continue from that point. This makes workflows flexible and controllable. So what we have done here is not just analyze data. We have built a pipeline, structured, conditional, and reusable. This is exactly how multi-step AI workflows are designed. The key takeaway is don't think of tasks individually. Think in sequences. Because real-world problems are not solved in one step. They are solved through chained actions. A well-designed workflow turns AI from a tool into a system. The key takeaway here is that Cowork allows you to design multi-step workflows that can adapt to the task. You can define actions, handle conditional steps, and review everything before it is executed. Plus, if anything goes wrong or you need to adjust mid-task, Cowork gives you the flexibility to pause, edit, and continue. Thanks for watching, and I'll see you in the next one. Hello, and welcome back. In the last video, we learned how to build multi-step workflows by chaining actions together. Now, we take that one step further because real workflows don't just run once, they build on past work. In this video, we will understand how Cowork uses memory and context across tasks and how you can use that to make your workflow smarter and more efficient. Let's start with the big idea. Cowork does not treat every task as isolated. It can remember previous work, use that memory, and apply it to new tasks. So, instead of starting from scratch every time, you are building on what has already been done. That's why memory is so powerful. It connects your past workflows, your current tasks, and your future workflows into one continuous system. Now, Cowork works with two types of memory. First is session memory. This is short term. It remembers what's happening within your current workflow, like recent steps and outputs. Second is persistent memory. This is long term. It stores context across sessions so you don't have to repeat instructions every time you come back. So think of it like this. Session memory helps you in the moment and persistent memory helps you over time. Now, let's quickly understand what is happening behind the scenes when we talk about persistent memory. Cowork does not just remember things magically. It actually uses a file-based memory system. There is a file called claude.md, which acts like a quick summary of important project context. There is a larger memory store where more detailed information is saved. As Cowork works, it automatically learns. It captures things like patterns, fixes, and preferences, and updates this memory over time. Now, instead of loading everything every time, it uses something called MCP-based retrieval. This means it only pulls the relevant memory when needed, which keeps things efficient. And to avoid clutter, it also cleans up memory in the background, removing outdated or duplicate information and keeping only what's important. So, overall, the system works like a loop: load context, execute tasks, and update memory. And that's what allows Cowork to improve over time and without you repeating everything again and again. But of the most useful things you can do is reuse previous outputs. Instead of starting from scratch, you can simply say something like, use the report generated yesterday as a template. Cowork will pick that up and build on it. This makes your workflows faster, more consistent, and much easier to scale. Now, let's talk about how you can actually use persistent memory. You can store things like project level context, reusable task templates, and even your preferences. So, over time, your workflow becomes more standardized. You don't need to repeat the same instructions again and again. Cowork already understands how you like things done. Apart from memory, you can also explicitly provide context. You can paste data directly, upload files, or even link entire folders. The key idea is simple. The better the context you give, the better Cowork performs. So, memory helps in the background, but context is something you actively control. Now, while memory is powerful, it needs to be managed carefully. If your context becomes messy or outdated, it can actually lead to incorrect results. So, keep your memory clean, use clear references, and update or reset things when needed. Think of it like maintaining a workspace. Clean inputs lead to better outputs. Till now, we have seen how to execute tasks and chain them. But in real world systems, tasks are not isolated, they are connected over time. Think about how you learn anything. You don't start from scratch every day. You build on previous knowledge, you improve based on feedback, and then you adjust your next steps accordingly. So, today, instead of doing a one time task, we are going to simulate something much more powerful. We are going to build an AI learning system that remembers, adapts, and evolves over time. Not just responses, but continuity. So, for this hands on, let's move to our Claude app. Every intelligent system needs a foundation. So, the first thing we do is define a learner profile. This is not temporary, this is persistent memory. I'll write the prompt. Here, we define the learner's goal, their current level, and their preferences. This step is critical because now, instead of repeating these instructions in every task, the system remembers them. So, future outputs automatically align with this profile. Over here on my screen, you can see how the learner's profile has been created. The goal is to learn ML in 4 weeks with the level of beginner. And the style has also been created. Now, let's start the actual learning process. This is where we create the first layer of session memory. Now, notice something important. We are not just generating notes. We are also tracking what was learned, tagging difficulty level, and storing this as context. This becomes the reference point for all future sessions. Over here, you can see the first lesson has been created. You can go to the MD file that it created and look at the notes. The description of supervised learning with a real-world analogy, since we asked it to provide real-world examples. Then after that, unsupervised learning, then comparison between supervised and unsupervised. Now, here is where most basic systems fail. They repeat information, but we don't want repetition. We want progression. So, I'll ask the Claude Cowork to use the previous session and build on that. The topic is model evaluation. Build on earlier concepts, avoid repeating basics, maintain beginner-friendly tone. This is where context is being reused. Instead of starting from zero, the system knows what was already covered. It avoids redundancy and it builds logically on top. This is what makes the experience feel continuous. On my screen, you can see that the lesson 2 is model evaluation. It is following the learner's profile that I created earlier. Let's take this one step further. A good learning system does not just teach, it evaluates. I'll ask it to generate a quiz based on the previous 2 lessons. It should evaluate if the score is less than 60%, identify the weak areas, else increase the difficulty level. This is where memory becomes actionable. We are collecting performance data, interpreting it, and using it to guide future behavior. So, now the system is not just remembering, it is making decisions based on memory. Over here, you can also see the progress tracker it created from week 1 to week 4. So the quiz has been created. Let's try to attempt that one. If you want, you can also ask it to create the interface for the quiz one so you can attempt it directly on your screen. So let's say my score was greater than 60%. Logically, it should increase the level of difficulty of the quiz. Or if you want, let's make a lesson of adaptive learning. We should see how the system adapts. Like if weak topic exists, we could ask the system to re-explain with simpler examples, introduce the advanced topic. Also, we can ask it to apply the preferences that we described earlier, use analogies, keep summaries short. Over here, you can see, since I iterated that my score was greater than 60%, it added an advanced topic that we can cover. It also updated the tracker it created that 3 lessons has been done plus 1 quiz. It also increased the difficulty level for week 2. Now, let's zoom out. So far, we have been working session by session, but real systems also look at long-term progress. So here I have asked the Claude to use all sessions, generate summary, identify strengths, identify weak areas, and create a revision sheet. So the revision sheet should be created based on the 3 lessons that we created earlier. This step uses accumulated memory, not just the last task, but everything we have done so far. You can see how this all sessions memory has been created. It included the first lesson that we created, supervised versus unsupervised, then the model evaluation, the quiz one, and then linear regression. The difficulty status is also here with the summary of all the lessons. But one important thing that you should take into consideration, memory is powerful, but it needs control. If memory is not managed, it can become noisy, outdated, or even harmful. So maintaining clean, relevant context is critical. So you can also prompt the model, if outdated info exists, then remove that. If conflicting preferences are there, prioritize the latest one. Let's step back and see what we built. We started with a simple learning session and ended up with a system that remembers, tracks progress, adapts to performance, and personalizes output. That's not a prompt anymore, that's a system. Think about your own work. How often do you revisit old work, improve based on feedback, and plan next steps? That entire loop can now be handled by AI. Memory and context are what transform AI from a question answering tool into something that can actually support long term workflows. An AI that remembers your past can intelligently shape your future. Hello and welcome back. In the last few videos, we explored how Cowork execute tasks and build workflows. Now, we shift our focus to something even more important, the outputs of those workflows. In this video, we will understand what artifacts are in Cowork and why they are central to everything you build. So, what exactly are artifacts? Artifacts are simply the outputs created by Cowork. Every time you run a task, Cowork produces one or more artifacts, and these are what you actually use. So instead of thinking about tasks as the end goal, think of artifacts as the real outcome, because workflows only matter if they produce something usable. Artifacts can come in many different forms. They could be documents, spreadsheets, code files, summaries, reports, or even images. The format may change, but the idea stays the same. Cowork is creating something structured that you can actually use, edit, or share. Different formats, same concept, the output. Now, here is what makes artifacts powerful. They are AI generated. When you give a task, Cowork does not just respond. It decides when to create a structured artifact like a document or a report. The key to getting good artifacts is giving clear instructions and output formats. And once created, these artifacts are not static. You can refine them, reuse them, and build on top of them. So, the shift here is simple. You are not just getting answers, you are creating usable artifacts don't just get created and disappear. They follow a life cycle. They are created as part of a task, saved for later, updated over time, and then reused or shared. So, artifacts are not one time outputs. They become reusable building blocks as your workflow evolves. To manage all of this, Cowork gives you the artifact panel. This is where you can browse your outputs, preview them, rename them, and reuse them. So, instead of searching manually, everything is organized in one place, like your personal workspace for outputs. Now, let's quickly look at how artifacts are controlled. In most cases, artifacts are enabled by default, but you can manage this from settings. By going to the capabilities section. If you disable artifacts, Cowork will still generate outputs, but they will appear as simple chat responses instead of structured files. So, enabling artifact is what turns Cowork from a chatbot into a workspace. Now, here is an important distinction. Some artifacts are temporary. They exist only within the session. Others are saved, meaning they persist across sessions and can be reused later. So as you work, you need to decide, is this something I just need now or something I'll reuse later? Artifacts are not just outputs, they can also become inputs. You can rename them, organize them, and reuse them in workflows. So instead of recreating work again and again, you can simply build on what already exists. This is where Cowork starts to feel like a system and not just a tool. Now, here is where artifacts become even more powerful. In the previous slide, we saw that artifacts can be reused in workflows, but we can go one step further. They can actually store data across sessions. This means artifacts are no longer just outputs, they become stateful systems. For example, you can build things like journals, trackers, or collaborative tools where data keeps updating over time. There are two types of storage. First, personal storage, where data is private to each user. Second, shared storage, where everyone interacting with the artifact sees the same data. One important thing to remember, this feature is available only on paid plans, and it works when artifacts are published, not during development. So at this point, artifacts are no longer just files, they behave more like applications with memory. While persistent storage is powerful, it comes with some constraints. There are limits on storage size and only text-based data is supported. Also, personal and shared storage are separate, and if an artifact is unpublished, all its data is deleted. So, always be mindful of what you store, especially in shared environments. For this hands-on demo, we will be building a mini product builder using artifacts. Before we begin, let's quickly make sure everyone has artifacts enabled because this feature is what powers everything we are about to build. So let's go to Claude app. You have to go to the settings section, then open capabilities. Over here, you'll see the artifacts section. Make sure this toggle is turned on. If it is off, you will only see outputs and chat, but not as structured, reusable artifacts. After that, we also have AI-powered artifacts. You can create apps, prototypes, and interactive documents that use Claude inside the artifact. Start by saying like, let's build an AI app to access the power of Claude API. You can also toggle that on. But for now, we are going to use artifacts only. So let's go back to a new task. Here I'm going to choose a different folder. I'll go to my desktop and choose the artifact. Now, let's shift how we think. Until now, we have been generating output, but with artifacts, we are creating something much more powerful. Structured outputs, reusable assets, and building blocks for systems. So today, we are not just running a task, we are going to build a mini system using artifacts step by step. We will build a simple but realistic system, a daily productivity tracker. And instead of doing everything in one go, we will create artifacts, evolve them, reuse them, and combine them. Let's start by creating our first artifact, a reusable template. For that, I'm going to prompt the model, create a daily productivity log template, which would include date, task completed, time spent, notes with the format of Markdown. Then you have to save that as productivitytemplate.md. This is our first artifact. This is not just output, it is reusable. We can now use this again and again. So let's run this one. After the artifact is created, we would use this artifact to create actual data. Over here, we can see that the template has been created. The daily productivity log with a sample date, the task completed with different kind of status. Then it has also created the time spent per activity, the start duration, end, and the duration between start to end. We also have a note section where any observation, blockers, ideas, or follow-ups can be included. After that, we have tomorrow's priorities section as well. Over here, we can see that the Claude says, just duplicate the file each day and fill it in. We don't have to create the template again and again. We can just fill it up whenever we want. So let's use this particular artifact. I'll prompt the model, use this particular artifact, create entry for today. Fill all fields, add 3 tasks, and save that as log for day1.md. Now, we are not starting from scratch. We are building on top of an existing artifact. This is how workflows begin. Over here, we can see how we ask Claude to fill all the fields, add 3 tasks, and save it as a particular file name. It did all that by adding the task name, the start time and end time, and the notes. So now let's transform this into another format. I'll ask Claude to change the format from MD to CSV file, and the columns should include task, time spent, and the status. Same data, new artifact with a different use case. Artifacts are flexible. They can evolve across formats. You can see how it created a different format with same entries. Now, let's improve our system. I'll ask Claude to update productivity template by adding priority, mode rating, and save it as template 2. This is versioning. Instead of replacing old template, we create a new version. Keep the old one intact. This is exactly how real systems evolve safely. Now, the new version has been created. Now we'll use this improved version to create an entry for day 2. Every new output follows the improved structure. This is how systems get better over time. You can see how it was reading the template too, because we specifically asked it to use that template. You can see how it added 5 more tasks, the time spent, the mood and energy section with tomorrow's priorities. Now, let's connect everything together. We'll ask it to use the log of day 1 and day 2, then generate the weekly summary, total time spent, and the most frequent tasks that occurred. We are basically combining multiple artifacts together. This is where artifacts becomes powerful. They don't just store data, they feed into future workflows. You can see on my screen, the overview has been created with total number of total tasks and how many tasks are completed and in progress. The total time spent, average time per day, and a different section is also there with total time spent by task. Let's connect this to what we learned. We have created artifacts, saved them, versioned them, reused them. This is the complete life cycle in action. If we hadn't saved these artifacts, they would disappear after the session. But since we saved them, they persist and can be reused anytime. That's the difference between temporary and saved artifacts. In real-world workflows, templates, reports, dataset, all of these are artifacts, and over time, they become reusable systems. To summarize, artifacts are not just outputs, they are building blocks that allow you to create systems, maintain consistency, and scale your workflows. Let's quickly recap. Artifacts are structured outputs created by Cowork. They can take many forms and follow a life cycle. Create, save, update, and reuse. You can refine them using natural language, control them from settings, and even use them as building blocks for workflows. So, the key idea is simple. Artifacts are not just results, they are reusable assets. That's it for this video. Now you understand what artifacts are and why they are so important in Cowork. Thanks for watching and I'll see you in the next one. Hello and welcome back. In this video, we are going deeper into how Cowork remembers. Not just what memory is, but how its memory architecture is structured and how it supports tasks across the current workflow, the active session, and future session. A useful way to understand this is through 3 layers. What Cowork is actively working on right now, what it remembers during the current session, and what persists across sessions. In practice, this persistent layer includes things like project memory, global instructions, folder-level instructions, and in Claude Code, structured context through files like claude.md and auto-generated memory. Here is the easiest way to understand the architecture. Working memory is what Cowork uses right now while handling the current task. Session memory helps it maintain continuity during the active session. Long-term memory is what carries context forward across sessions, so you don't have to repeat everything each time. This long-term layer typically includes things like project memory, saved memory summaries, and persistent instruction files such as claude.md. Not everything gets saved. Claude's memory systems are designed to focus on useful, recurring context. Things like your role, project details, working style, technical preferences, and repeated corrections. You can also save memory more intentionally by giving standing instructions. In Cowork, Anthropic documents global instructions and folder instructions. In Claude memory, users can also explicitly tell Claude what to remember. Under the hood, persistent memory works like a loop. Relevant memory is loaded, injected into the task context, used during execution, and then updated if needed. In Cowork, this includes project memory, global instructions, and folder instructions. In Claude Code, Anthropic documents two persistent mechanisms, Claude.md which you write and auto memory which Claude writes itself based on corrections and patterns. Both are loaded at the start of every session. Now, let's understand how memory actually behaves across sessions. When a session ends, your conversation history does not carry forward, but your files and stored memory still exist. To maintain continuity, Cowork relies on what we think of as a memory stack, typically a running summary along with the relevant files. This allows the system to work across large amounts of information without exceeding limits. There is also a background process where insights from past work can be extracted and structured into memory. So overall, the workflow looks like this. Load context, then execute tasks, and then update memory. Memory is not hidden. Anthropic's memory doc says users can go to settings and then capabilities to view and edit memory, add new custom memory, pause memory, or reset memory entirely. Resetting memory permanently deletes the memories, including project memories, and starts afresh. The best results come from clean memory. Anthropic's docs recommend keeping persistent instructions specific and concise because long or conflicting memory reduces the reliability. The same principle applies here. Store what matters and remove what is outdated, and keep memory aligned with the current workflow. Claude's memory systems are useful, but they work best when they stay relevant. Now, while memory is powerful, it does have limitations. There are size constraints, which means older memory may eventually be truncated. Also, memory does not automatically sync across devices. This means you may sometimes lose continuity or need to reload context manually. To overcome this, advanced setups use external memory systems. For example, vector-based memory solutions that allow better long-term recall. But for most workflows, the key is simple. Keep memory clean, relevant, and intentional. The key takeaway is simple. Cowork becomes more powerful when it can carry context across time. But that only works well when memory is layered, relevant, and under your control. So think of memory not as a hidden feature, but as part of workflow design. That's it for this video. Thanks for watching and see you next. Hello and welcome back. In the previous videos, we explored how Cowork handles tasks, artifacts, and memory. Now we are bringing all of that together. In this video, we will learn how to create a persistent project context. So instead of repeating instructions again and again, you define it once and reuse it across tasks. Let's start with the big idea. A persistent project context allows you to create a reusable working environment. You define your context, attach your files, and set your rules. And Cowork applies all of that automatically to every task. So instead of repeating instructions, you simply switch context. So, what exactly is a project? A project is a structured workspace. It combines three key things: your files, your memory notes, and your default instructions. And once this is set up, the context stays active across tasks. So, one setup leads to multiple tasks. Now, let's see how to create one. You start by giving your project a name, then attach a working folder, add memory notes if needed, and define default instructions. Once this is done, your project is ready, and Cowork now understands how to operate within this context. This is where things get really powerful. You can define project level rules, like where files should be saved, how output should look, or what format to follow. For example, always save to a specific folder, or always follow a certain report format. And the best part, these rules are applied automatically. Start with aboutme.md, where you define your role, team, and priorities. Then the brandvoice.md, which controls tone, style, and phrasing. And finally, the workingstyle.md, which defines how Cowork should behave. These files act as a base layer of context for every task. Now, let's organize everything properly. Create a main folder, something like Claude Cowork. Inside that, separate your context, projects, templates, and outputs. This structure helps keep your system clean and organized. And more importantly, it ensures Cowork can use the right context at the right time. Now, here is the key idea. Once your project and context are set up, Cowork automatically injects this context into every task. You don't have to repeat anything. Every task already knows where to save, how to format, and what rules to follow. So the system becomes much more efficient and consistent. Now, let's see why this matters. Run the same task in two different projects, one personal and one work. In a personal project, the output might be informal and flexible. In a work project, it will be structured and rule-driven. Same task, completely different outcome. And that difference comes purely from context. Projects are not fixed, they evolve over time. You can update rules, add or remove files, and refine memory notes whenever needed. The goal is to keep your project context relevant and clean, because the better maintained your project is, the more reliably Cowork can operate. Now, let's talk about long-term usage. As your project grows, context can become bloated. To prevent this, use a claude.md file to guide context loading. Also, treat repeated corrections as signals, convert them into permanent instructions, and regularly archive completed work to keep active projects clean. Clean context leads to better performance. Once a project is complete, you don't have to lose it. You can archive it and export its artifacts and memory. This allows you to reuse past work, maintain records, or build on it later if needed. Across the last few modules, we have learned different pieces: how to chain tasks, how to use memory, how to create artifacts. Now, the question is, how do we bring all of this together into a real system? Today, we are going to build something that feels like an actual product, an AI Creator Studio. This system will generate content, structure outputs, remember preferences, reuse previous work, and maintain consistency. Let's start with our hands-on by going to the Claude app. Let's start by creating our project by going to the project section, then clicking on new project. I'll start from scratch. I'll give it a name as Creator Studio. For instructions, I'll give 3 instructions as of now. Always structure the output, save all outputs in the separate outputs folder, and reuse previous artifacts when possible. So I'll create over here. You can see that the folder has been selected on its own. This defines the base behavior. Now, every task inside this project will follow these rules automatically. Now, let us add the persistent memory by defining our preferences. Keep the content concise, include actionable insights, maintain engaging tone. This becomes persistent memory. We don't repeat this again and it is remembered. Now you can see over here that the set content and communication preferences has been done. After that, we'll add the context files. As we discussed in our previous slide about me.md, the brand voice, and the working style. This is the intelligence layer. It controls tone, structure, and behavior without needing prompts. You can see over here how it's done. The role has been created with the brand voice, the working style, and the project setup. Now you can prompt it further. The phase 2 will come from here, the multi-step workflow execution. So for that, let's start our workflow. I'll go back to the Creator Studio. And over here, I have prompted the model generate 5 content ideas based on productivity. This creates our first artifact ideas. Let's go to over here. You can see it has provided us with 5 different kind of content ideas. The 2-minute rule, by small tasks are silently killing your deep work. I tracked every minute of my workday for 30 days, and here is what actually wasted my time. You can even make it more customized to your profile. I'll give a different kind of task, which would be our artifact 2. From the top 5 ideas, I needed to select the best idea, generate the video script, and the hook. Now we are building on the previous output. This is chaining plus artifact reuse. It picked the best idea out of all 5 as the strongest because it combines a personal experiment, data-driven reveals, and a universal pain point, ideal for short-form video. It also recommended a selected hook. I tracked every single minute of my workday for 30 days. I thought I was working 8 hours. Turns out I was actually productive for 2 hours and 47 minutes. And the thing stealing the most time, it was not social media. So I would say this is engaging as well as attractive as well. The full package includes the selected idea rational, 3 hook variations, a timestamped 75 to 90-second video script with hook setup, rank reveal, insight, results, CTA. Over here in the script, no, this is not the script. This is like a documentation that it created. It also defined why it chose that particular idea, and it gave us some alternate option for hooks. And this would be the script. I tracked so the script is very well time stamped. You can go over here to see the script as well. Now, I'll prompt it further, like from script, generate the caption, hashtag, and title variation. One input is leading to multiple outputs. You can see how we started with a simple prompt, like give me top 5 ideas, and from there we iterated it further, like choose that one idea out of the top 5, and from that generate a script. And now from that script, we are generating the caption, hashtags, title variation. This is asset generation. You can see how it gave us the output, the title highlights for different kind of platforms, YouTube, TikTok, LinkedIn, and different kind of formats it provided us. You can see the hashtags as well. Over here, we'll go to the social media package. You can see the different kind of variation it gave us. This is very detailed, and I would say, yeah, it works for us. Okay, let's iterate further and organize everything into a structured file. This is now a reusable artifact, not just text. If you remember, in the starting only, we defined our tone, like what kind of tone we wanted, what kind of person I am. After the output is generated, we'll try to refine it according to our preferences. And instead of defining those preferences again, we will use the memory to get those things. You can see how the document has been structured. Let's look at that. The section 1 includes all the title variations across different platforms. The section 2 includes the script. The section 3 includes all the captions, 3 variations for different platforms. And the fourth section includes the hashtags. So let's look at that. These are all the titles that we can go for. The captions for different kind of platforms we have. If you want, you can also customize the different kind of platforms you use, and the hashtag you should go for. like if you want SEO-friendly hashtags, captions, or descriptions, something like that. Now, we are going to refine the content. This time, notice something important. I'm not going to repeat any instructions about tone, structure, or style because all of that is already stored in memory. I'll give it the prompt. Improve the previously generated content. Align with project tone, make it more engaging, keep it concise. Now, what's happening here is very powerful. Even though I gave a simple instruction, the system is automatically pulling in the brand voice from context files, the tone preferences from memory, structured rules from the project. So, behind the scenes, it's not a simple rewrite, it is a context aware refinement. Over here, it has created the task list, rewriting content with sharper data-driven tone, regenerate docs with tightened content, validate and share improved file. This is exactly why we don't repeat prompts. We rely on memory to maintain consistency. You can see the version 2 is ready, tighter, sharper, and leaning into the data-driven voice that fits the Creator Studio's analytical tone. In our preferences, we define how we use the analytical tone. So according to our preferences, it generated the content. You can see how it aligns with our preferences over here. Now, let's take this one step further. Instead of creating something new, we are going to reuse what we already built. I'll say use the previous script and convert it into a LinkedIn post and an email newsletter. So let's see what kind of content it generates. Now, this is a critical concept. We are not generating from scratch. We are taking an existing artifact, transforming it into new formats like a script to a post, or basically to content to a post, while keeping context intact. So, same content, different format, same project rules applied automatically. This is how real systems scale content. Now, I want you to observe something carefully. What we did not specify in the last few prompts, we did not specify structure, tone, formatting, or even where to save the file. Accordingly, now we'll observe what kind of outputs it generates, whether it includes the structure or tone or formatting like we wanted. Over here, you can see the output followed the same structure, matched the same tone, and aligned with the same style. Why? Yet the output followed the same structure, matched the same tone, and aligned with the same style. Why? Because project context is automatically injected into every task. This is the shift from controlling every step to defining behavior one. Now, let's make this system a bit smarter. Right now, it generates and improves content. But what if it could decide what to do next? We'll ask the model to basically apply the following rules. If the content is too long, shorten it. If the engagement is low, improve the hook. Now, we have introduced decision making. The system is no longer just executing instructions. It is evaluating output and adjusting it. You can also integrate your LinkedIn or different kind of social media platforms that we will be observing how to do in our further sessions. This is where workflows become intelligent. If you want, you can also generate the images using the model instead of getting the content in our text format. You can see how both the rules have been applied. Since the LinkedIn post included 220 words, now it has been reduced to 140. And the newsletter included 450 words, it has been reduced to 290 words. You can also see the rule 2 has also been applied. Let's look at the document it created. You can see it has made the comparison table as well. Like the version 1 hook was this and the version 2 is this. Now, let's take this one step further. Instead of improving once, we want the system to continuously evolve. For that, we'll create a loop. I'll prompt the model after generating the content, suggest improvement, refine the output, and store the improved version for future use. Every output gets evaluated, gets improved, and becomes the new reference. So, over time, the system gets better and better. This is how systems evolve, not just respond. Let's pause for a moment and understand what we actually built. We did not just generate content or run prompts. We built a system that remembers past context, reuses existing work, and structures outputs consistently, improves itself over time. Remembers, reuses, structures, and improves. Now, think about your own workflow. How often do you repeat the same instructions? Reuse old content manually. Maintain the same format again and again? All of that effort can now be handled automatically by the system. To summarize, when you combine project context, memory, artifacts, and workflows, you move beyond individual prompts and start building systems. You are not using AI anymore, you are building with it. Let's quickly recap. Projects allow you to define context once and reuse it across tasks. They combine files, memory, and rules into a single workspace. Context is automatically applied, and the same task can produce very different outputs depending on the project. So, the key idea is simple: set it once and reuse it everywhere. That's it for this video. Now you know how to build and use persistent project context in Cowork. Thanks for watching, and I'll see you in the next one. Hello and welcome back. In the last few videos, we focused on how Cowork works internally, tasks, memories, and workflows. Now we are stepping outside that system. In this video, we will understand MCP, the Model Context Protocol, and why it is essential for connecting Cowork to the real world. Let's start with a big idea. MCP stands for Model Context Protocol. Think of it as the bridge. It allows Cowork to move beyond your local system and interact with external tools and applications. Without MCP, Cowork works in isolation. With MCP, it becomes part of a connected ecosystem. And that's where real work begins, when AI can actually interact with your tools. Let's simplify this further. MCP is essentially a communication layer between AI and tool. Instead of building separate integrations for every app, MCP provides a standard interface. So one protocol can work across many tools. That's why we say one protocol, many tools. Now, let's understand why this matters. Without MCP, Cowork is limited to local files. With MCP, it can access cloud apps, connect multiple systems, and automate workflows across tools. So the shift here is from isolated work to connected workflows. And that's what makes Cowork truly powerful. Here is how the process works. You give a task, Cowork decides whether it needs external data or tools. If yes, it makes a tool call through the MCP. The tool responds and Cowork continues execution. So, the AI is not just responding, it is actively deciding when and how to use tools. Now, let's compare the two approaches. Native integrations are built in, but limited in scope and flexibility. MCP connectors, on the other hand, are pluggable and expandable. This means you can connect Cowork to many tools without being restricted to what's built in. So, MCP gives you flexibility, while native integrations give you fixed functionality. There are many MCP connectors available today. These include tools like Google Workspace, Microsoft 365, Notion, Slack, GitHub, and Airtable. Together, they cover most real-world workflows from communication to data to development. So, MCP is not just a concept, it connects to tools you already use every day. Now, let's talk about security. MCP connections use OAuth-based authentication. This means you explicitly grant access, define permissions, and retain full control. And if needed, you can revoke access anytime. So even though Cowork connects to external systems, it does so in a secure and controlled way. Let's look at this through a real scenario. Suppose your goal is to track action items from emails and keep your team updated. Cowork can read your emails from Gmail, extract tasks, and update them in Notion, and then send a summary to a Slack. So, instead of jumping between tools manually, you define one goal and Cowork executes the entire workflow. That's what MCP enables, end-to-end automation across tools. Now, let's see how you manually connect MCP in a Cowork. There are a few ways to do this. The simplest is using pre-built connectors. Just go to Settings, choose a tool, and authenticate. For more advanced use cases, you can add custom connectors by providing an API endpoint and credentials. You can also run local MCP servers, where you can configure tools directly in your system. And if you are using Cowork in a more advanced mode, you can use the /MCP command to manage an authorized connection. Depending on your use case, MCP can be simple or highly customizable. Let's quickly recap. MCP is the protocol that connects AI to tools. It enables cross-platform workflows. Connectors expand what Cowork can do, and everything works securely under your control. So, the key idea is simple. MCP transforms Cowork from a standalone system into a connected automation engine. That's it for this video. Now you understand what MCP is and why it matters. Thanks for watching. I'll see you in the next one. Hello and welcome back. In the previous video, we understood MCP and how it connects Cowork to external tools. Now, we are going to make that practical. In this video, we will connect Cowork with real productivity tools like Notion, Slack, and Airtable, and see how to build workflows across them. Let's start with the big picture. Cowork supports many connectors, and in this video, we will focus on a few key ones like Notion, Slack, and Airtable. But before that, let's understand what connectors actually are. Connectors in Cowork are MCP-based integrations that allow Cowork to connect with external applications. This means Cowork is not limited to your local files. It can directly access, read, and act on data inside tools like Gmail, Notion, or Slack. So, instead of behaving like a chatbot, it starts functioning like an actual AI coworker that can work across systems. And that's the key shift from single task interactions to connected workflows. Before we start using Notion, we first need to connect it to Cowork. Go to Settings and open the Connectors section and select Notion. You will authenticate using your account and grant permissions. This allows Cowork to access your workspace. For advanced use cases, you can also connect Notion using its API. Once this setup is done, Cowork can start interacting with your Notion data. Now that Notion is connected, let's see what Cowork can actually do. It can read from databases, create new pages, update properties, and append content to existing documents. So, instead of manually managing your workspace, Cowork can directly interact with your Notion data and automate these operations. Before running workflows with Notion, it helps to prepare the setup properly. First, create a clean folder structure. For example, one folder for active work and another for reference material. This makes it easier to control what Cowork reads or edits. Second, add clear project instructions that explain how your Notion database is structured. The better Cowork understands your schema, the more accurate the results will be. And if you need a more advanced setup, you can also use the Notion API directly by creating an integration secret and managing access through Notion's integration settings. Now that setup is clean, let's see the workflow in action. Cowork reads the roadmap, finds the blocked items, and turns that into a structured summary you can use immediately. Cowork reads the roadmap, finds the blocked items, and turns that into a structured summary so you can use immediately. So first, let's see how to connect Notion to our Claude Cowork. You have to go to the Claude app. Once you have opened the Claude app, go to the Customize section. Over here, you'll see the connectors. Go to that and you have to select the Notion one. I've already connected my Notion to the Claude Cowork. Over here, you can also configure the tool permission settings, like whether to allow these kind of things or not, like read-only tools, Notion Fetch, Notion Get Comments, Notion Get Teams. You can also customize these things. We have three options: always allow, needs approval, or blocked. After this part is done, we will move to our hands-on section. Before we start, I want to set expectations clearly. Most demos you have seen so far probably look like this. You already have a Notion workspace, you already have a database, you already have data, and then AI just helps a little bit. What we are going to do is very different. We are starting from zero. No pages, no tables, no data, nothing. I'm not going to click around in Notion. I'm not going to create fields manually. I'm not going to paste any data. Everything you are about to see will be created entirely by AI inside Notion. By the end of this demo, we will have a structured workspace, a working task system, realistic project data, insights generated from that data, and actual updates made to the system. Think of this as onboarding a new team member, except that team member is AI. Once Notion is connected to our Claude Cowork, we will run a prompt where it will help us to create the system. So let's go to our Claude app. I'll create a separate project. I'll give it a name, Notion Workspace. And over here, I'll add my first instruction. Create a structured workspace in Notion. Create a page titled Project Ops Hub. Inside it, create a database called tasks with the following properties: task name, status, owner, priority, and blocker reason. Add 8 realistic tasks with a mix of statuses. At least 3 should be marked as blocked. Include meaningful blocker reasons. Make it look like a real working project setup. This is only for our demo purpose. So let's see. Notice what I'm doing here. I'm not giving step-by-step UI instructions. I'm describing the structure, the logic, the intent. AI understands systems, not just commands. Over here, you can see the connectors, and you'll see that the Notion toggle has been turned on. See over here, since I wanted to create a new page, it is asking for my permission. So I'll allow once. Over here, let's see the task list. Creating the Project Ops Hub page in Notion. Creating the task database with required properties. Adding 8 realistic tasks with mixed statuses. And then verifying the workspace structure and shared links. So I'll allow it again. You can see that the Project Ops Hub page has been created. It is showing the status as completed. After that, the task database with required properties has also been completed, and the 8 realistic tasks with mixed status is in progress. So you can see all the tasks that have been completed and some of them are pending. Let's actually slow down and look at what is happening. A page was created, Project Ops Hub. Inside that, a database was created. Fields were definitely correct. Statuses are structured and data was populated. Over here, it has also given us the hyperlink to that particular page with the database and all the tasks. If you want, you can just click on one of them and go to the direct link. Think about what you would normally do. Create table, add columns, define options, and enter rows. That entire setup phase just disappeared. This is not just faster execution. This is removal of setup overhead. How many of you delay creating systems because setup feels like work? That friction is now gone. So let's look at the results it created on the Notion interface. You can see on my screen how it not only created the Project Ops Hub page, but also listed the task in a very definite manner. It has all the properties, the task name, the blocker reason, owner, priority with the statuses. So let's iterate it further. Now we are going to use the same system, but for a completely different purpose. Here, I will basically ask, go to the task database, identify all tasks where status is equal to blocked. Then analyze the total number of blocked tasks, common blocker reasons, any pattern across owners or priorities. Then write a concise internal update summarizing key issues. Up until now, AI was acting like a builder. Now, it is going to act like an analyst. So, over here, you can see on my screen how it is asking for the permission again. You can configure these settings by going to the connector section. Let's allow for this task. You can see the weekly update. Look closely at the output. It counted how many tasks, grouped the reasons. It did not just repeat data, it interpreted it in a comparison table manner. Dashboard show data. AI explains it. You can see on my screen how it analyzes all the patterns worth flagging. All the blockers are cross-functional dependencies. This is a coordination problem, not a capacity one. No single owner is a bottleneck since each block task sits with a different DRI. High priority is disproportionately affected with 2 of 3 high items stalled. Over here, you can go to the Project Ops Hub and see the data by yourself. Let's go a little deeper. If you had to do this manually, you would filter, scan rows, identify patterns mentally, write an update. That cognitive load is now offloaded. What part of your job feels like this? Mostly reporting, tracking, and etc. That's exactly what AI replaces first. Repetitive thinking. Now, we'll ask the AI to take action inside the Notion. I'll ask it from the block task, update each block task by adding a note inside the page. Summarize the blocker clearly, suggest a next step. For high priority block tasks, clearly mark them as needs immediate attention. Then keep updates clean and structured. This is the most important part of the demo. Most AI demos stop at insights, but real work does not stop at insights. It moves to action. Over here, you can see the progress task list it has created, and it is doing all the tasks one by one. Now, look at what happened. It opened individual task entries. It added contextual notes. It suggested next steps. It flagged urgency. This is not just analysis. This is execution inside the tool. Think of a project manager. Reviews, blockers, add notes, assigns urgency. That's exactly what just happened. We started with absolutely nothing. No workspace, no database, no task. In a few prompts, we now have a structured system, realistic working data, insights from that data, and actions applied to that data. AI did not assess workflow, created and ran the workflow. Going forward, the skill is not learning every tool deeply. The skill is learning how to describe systems clearly. If you can describe the system, AI can build and operate it. Now, let's continue with our concepts. Just like Notion, we have another connector called Slack. Before using Slack, you need to connect it through the connector section. Authenticate your Slack workspace and grant access to relevant channels. You can also control permissions depending on whether you want to read-only or full automation. Now, let's move to Slack. With Slack connected, Cowork can send messages, read channel history, and post formatted updates. It can also trigger notifications based on workflows. So, Slack becomes your communication layer, where outputs from workflows are shared automatically. For Slack, structure matters. Use dedicated channels for workflows and keep outputs formatted and consistent. Also, be mindful of permissions, like we did for Notion. Not every workflow needs write access. Another connector example we have is Airtable. To connect Airtable, go to the connectors section again and authenticate your account. You can control which bases Cowork can access. For advanced setups, you can also use API keys. Think of Airtable as a structured database layer inside your workflow. Cowork can read records, create new rows, update fields, and trigger actions based on data. What makes this useful is the way it works. Cowork reads Airtable as structured data, understands the fields, records, and then uses the connector to send updates back to the base. That means it can check row values, decide what needs to change, and even trigger updates when new data or files come in. So, Airtable becomes both a storage layer and an action layer for automation. Airtable works best when the setup is clean and intentional. Start by defining clear field names and keeping the schema consistent because that helps Cowork understand the structure of your data correctly. It is also important to keep records clean and avoid duplicate or messy entries, since poor data quality can lead to unreliable automation. And if you are planning trigger-based workflows, make sure the table design matches the actual use case. So the better your Airtable setup is, the more reliably Cowork can read, update, and automate across it. Now, let's combine everything. We did a hands-on experiment on Notion, where Cowork reads the data from Notion, processes insights. You can also experiment with different connectors like Slack, Airtable, like we discussed in our previous slides. All of this happens from a single prompt. You can also do multiple iterations. So instead of switching between tools, you are orchestrating them together. Once you understand the pattern, you can build many different workflows. For example, you can track projects, automate customer support, manage sales pipeline, or even run content workflows. Each workflow simply connects tools like Notion, Slack, Airtable, or others, depending on what you need. So the real power is not in one workflow. It is in the ability to design your own. To make this work well, your prompt needs structure. You should clearly define each step: what to read, what to analyze, what to send, and what to store. Also specify the tools and outputs at each stage. So think in terms of a sequence. Read, analyze, notify, and then store. Now, a few best practices. Start simple. Use 2 or 3 tools per workflow. Keep your steps clear and ordered. Avoid unnecessary complexity and always validate outputs between steps, because clean workflows are more reliable. Let's quickly recap. MCP enables Cowork to connect with external tools. Notion, Slack, and Airtable form a powerful ecosystem. A simple prompt can trigger multi-step workflows, and clear prompt leads to better execution. So, the key idea is simple. Cowork becomes a workflow engine when connected to tools. That's it for this video. Now you know how to connect Cowork to real tools and build multi-step workflows. In the next video, we will take this even further into advanced automation. Thanks for watching, and I'll see you in the next one. Hello and welcome back. In this video, we are going to explore one of the most powerful features in Cowork: skills. By the end, you will know exactly what skills are and how they are different from just typing a prompt, and how to start using them in your daily work. A skill in Cowork is not a shortcut or a safe chat. It is a persistent instruction set, a blueprint that lives inside your Cowork environment. Every time you start a new session, your skills are already there. You do not need to re-explain your preferences, your format, or your steps. Cowork reads the skill and follows it. The best analogy is a standard operating procedure. You write it once and your team follows it forever. That is exactly what a skill does for your AI workflow. Here is how to think about the skill system in layers. At the top, you have the task what you want done. In the middle, you have the skill, the structured blueprint that defines how Cowork should handle that task. At the bottom, you have the output, consistent, formatted, and predictable. Without a skill, you type a new prompt every session and the output varies. With the skill, you trigger it once and Cowork follows the same logic every time. That middle layer, the skill, is what separates ad hoc AI use from reliable AI workflows. There are 3 ways to get skills into Cowork. First, via plugins. You browse the marketplace and install pre-built skill bundles with one click. This is the fastest route if someone has already built what you need. Second, via prompt. You just tell Cowork, create a skill for me, and describe what you want. Cowork asks you clarifying questions and generates the skill file automatically. Third, via Skills tab directly. You go to Customize and then Skills. and either browse Anthropic's library, build one manually, or upload a skill.md file you have written yourself. All three methods lead to the same place, a working skill installed in your environment. Skills and prompts are not competitors. They work as a team. The skill carries the logic, the structure, the steps, the output format. Your daily prompt carries the data. Here is today's file. Here is this week's report. Make this adjustment. Without skills, you are retyping the same 50-word instruction every session. With skills, your daily prompt shrinks to one line. The skill does the heavy lifting, your prompt just points to the right content. Let's go deeper on the differences. Skills are persistent. They live across every session, and Cowork can trigger them automatically when it sees a matching task. They are structured through a skill.md file that defines everything about how the task should be handled. One-off prompts are the opposite, temporary, manual, and inconsistent. Every time you rely only on a prompt, you are starting from scratch. The risk of getting a different format, a different structure, or a different result is high. Skills eliminate that variation by locking in the blueprint. Cowork comes with a growing library of pre-built skills from Anthropic. What you see here is a representative sample, not an exhaustive list. The library covers writing data, meetings, code review, translation, file management, and more. And Anthropic continues to add new ones. You can explore the full list by going to Customize, then Skills, and then Browse. Think of it as an app store for task workflows. You browse, you toggle on what you need, and those capabilities are immediately available in your next session. Every skill follows the same basic structure, which includes 4 key components. First is trigger phrase. This is what tells Cowork when to activate the skill. Instructions. Second is instructions, the steps Cowork follows to execute the task. Third is expected inputs, what Cowork needs from you to make the skill work. Fourth is output format, what the results should look like, or basically in what format. For example, if you're using the meeting notes skill, the input might be the meeting transcript and the output could be a formatted meeting summary. Here's the decision framework in 3 modes. Use a skill when the task repeats, has multiple steps, needs consistent output, or you want to share it with the team. Use a prompt alone when you are doing something for the first time or the task is truly unique and simple. But the most powerful mode is using both together. And this is where most experienced coworkers users end up. But the most powerful mode is using both together. And this is where the most experienced cowork users end up. You use the skill to set the structure and the logic, and your daily prompt to feed in the specific data or ask for a one-time tweak. That combination gives you consistency plus flexibility. There are 2 ways to trigger a skill. The first is natural language. You just type your request and Cowork automatically detects which skill to load based on your message, matching the skill's trigger phrase. This is the default and works seamlessly for most situations. The second method is the slash command. You type a forward slash followed by the exact skill name, like slash meeting notes formatter. This gives you direct, guaranteed control over exactly which skill runs. Use the slash command when you have multiple skills that could potentially match the same request, or when you are testing a specific skill and want to be certain it is the one being invoked. Before we talk about skills, I want to show you a very common behavior. Imagine this is your daily work. Summarize this report in bullet points. Keep it under 150 words, use a professional tone, and include key action items at the end. You can attach any sample paragraph or the report. Over here, I'll attach a sample report. I'll go to the files, then the downloads. I'll sample weekly report. Looks normal, right? Nothing wrong here. Now, imagine doing this every single day. Same instructions, same format, same structure. You're not doing new thinking. You're repeating instructions. This is exactly where skills come in. Instead of repeating instructions, we save them. So now we will talk about how to do this task that we usually do manually using the skills. In our previous slides, we talked about how to access skills in 3 ways. First is by going to the skills section. Over here, you can add and browse some new skills. The first way is this. The second is by creating your own skills. I selected the skill creator. And now I'll use the slash command and call that particular skill that I've added. I'll use the skill creator. This is the second method how to control your skills. Now, notice what I'm doing differently. I'm not asking for output, I'm defining a system. Here I have defined create a skill for me called weekly report summary. This skill should take a report as input, summarize it into bullet points with maximum 150 words with a professional tone. Add a section at the end with key cut. Add a section at the end, key actions with clear next steps. Make the output structured and consistent. So let's run this one. This is a one-time investment. Now, after the skill has been created, I never have to explain this again. I can just call my skill by using the hash command and just give the report as an input file. You can see on my screen how Claude Cowork is asking me some questions. It is regarding the skills. So, what input format should the skill handle? You can select even multiple. In the progress section, you can see the task priority list it has created. You can see over here, not only it will create the skill, but run the 3 test cases with different kind of formats. After the skill has been created, it will run all test cases with skill and without skill in parallel to basically compare the results. After that, it will draft the citations and grade the runs. After the skill is created, we will run our own test to watch the difference. You can see the summary report it has created. It ran its own test, and with the skill, the pass rate is 100%, but without the skill, it is 54%. You can see the detailed analysis over here. Let's wait for the skill.md file to be created. After that, we'll run our own test by using the slash command. Over here, I'll just say that continue with your task. Now you can see after my approval, it is generating the static eval viewer for review. And then it will iterate on the skill based on the feedback. After that, it will package the final skill as skill.md file. Over here, we can just save the skill. Cut. Now we'll use this skill to generate the summary report. I'll just call this skill by going here. And now I will attach my report. You can see the difference now. Same structure, same format, but no instructions. The skill carries the logic. The prompt only carries the data. Put both side by side. Without skill, you have to write full instructions every time. Risk inconsistency, more effort. But with skill, you can even write a one-line prompt, but same output every time. Zero repetition. This is not about saving time. This is about removing friction. If you have ever typed the same instruction twice, you should not be writing a prompt. You should be creating a skill. Most people use AI like a tool. Power users use AI like a system. Imagine having 10 skills for your daily work. You are no longer prompting. You are operating a system. Let's bring it together. A skill is not just a safe prompt. It is a persistent, structured blueprint that Cowork follows every time. You can add skills 3 different ways. Skills and prompts work as a team, not as alternatives. The built-in library is large and growing, and when you need direct control, the slash command gives you instant, precise access to any installed skill. In the next video, we will go deeper into global skill versus workspace skills and how to scope your skills correctly for different projects. That's everything you need to know about skills in Cowork. You now understand how skills differ from one-off prompts, what is available out of the box, and how to create your own. Thanks for watching and see you next time. Hello and welcome back. In the last video, we covered what skills are and how they work. Now, we are going a level deeper, focusing on the 2 types of skills you will use in Cowork, global skills and workspace skills. By the end of this video, you will understand the difference between them, how to use each, and how to resolve conflicts when both are triggered. The first question you should ask when deciding between a global or workspace skill is, does this skill apply to everything I do or just one specific project? If it is universal and applies across all projects, it is a global skill. If it is tailored to a specific project, it is a workspace skill. This simple framework will guide you in choosing the right skill for your needs. Let's start with global skills. These are skills that are available across all projects and sessions. Once installed, a global skill works everywhere, making it ideal for universal workflows that apply to your role as a whole. For example, a meeting notes formatter or data cleanup routine. These types of tasks should be global skills because they are relevant no matter what project you are working on. Now, let's talk about workspace skills. These are designed for a specific project and are only active when that workspace is open. For example, if you're working on a product marketing brief for a new launch, that logic is specific to that project and would be a workspace skill. These skills are great for client-specific or domain-specific logic that only applies in one project, ensuring the right context is applied. Here is a direct comparison to highlight the key differences. Global skills apply across all projects, while workspace skills are limited to a single project. Global skills are always active, whereas workspace skills are only active when that project is open. Global skills are perfect for universal workflows, while workspace skills are tailored for specific clients or domains. This is simple but effective framework that makes managing your skills easier. Managing skills is pretty straightforward. To activate a skill, just go to Customize section, then Skills and toggle it on. It is immediately active. If you need to deactivate a skill, just toggle it off. No need to restart or reprompt. You can also prioritize skill within the same scope. Workspace skills take precedence over global skills in the same session. You can even reorder them by dragging and dropping them in the list. Now, let's talk about conflict resolution. What happens if both a global skill and a workspace skill have the same trigger phrase? Simple. Workspace skills always win because they are more specific. If no workspace skill is triggered, the global skill takes over. To avoid conflicts, make sure your trigger phrases are specific and use workspace skills for anything that is client-specific. Let's quickly recap everything we have covered. Global skills are your go-to for universal tasks. They work across all your projects and sessions, making them perfect for tasks that repeat often. Workspace skills, these are tailored to your specific projects or clients, giving you that extra precision when you need it. Think of them as your project's personal assistant. And when both a global skill and workspace skill match the same trigger, no worries. The workspace skill takes the lead, giving everything project specific. Best part? Managing your skills is a breeze. You can activate, prioritize, and configure them easily within Cowork. So, by combining global and workspace skills, you get flexibility and efficiency, powering up your workflows like never before. That's it for this video. Now you know how to create and manage both global skills and workspace skills. Thanks for watching, and I'll see you in the next one. Hello and welcome back. In this video, we will take a hands-on approach to building a skill from scratch. By the end of this video, you will have created your first skill, added input variables, tested it, and even published it for your team to use. Let's get started. Here is the full path we will walk today. We will go step by step from defining the skill's name and trigger to writing clear instructions, adding variables, testing it, publishing it, and managing version control. Each step builds on the last. Let's dive in. Step 1 is all about defining the skill. First, we create a name for it. This becomes the / command, so keep it lowercase with hyphens. Then, we write a description that clearly defines the task. This description is important because Cowork will use it to decide when to trigger the skill. Think about what natural phrases your team will use to activate it. Those go into your trigger keywords. Now, let's write the instructions for the skill. Use numbered steps so Cowork knows the order to follow. Be explicit about the output format. Don't just say output a report. Say output a Word document. Also, include quality checks. If data is missing, have Cowork flag it. The clearer the instructions, the better the results. Input variables are what make your skill dynamic. For example, report date allows you to customize the date without changing the skill each time. Defining your variables clearly and make sure the user knows what values to input when prompted. Testing is critical. First, test the happy path with perfect data. Then, run edge cases, what happens when there is missing data. Finally, test the trigger. Make sure your skill activates when it should, even if someone uses a slightly different phrase. Thorough testing ensures your skill will work flawlessly when live. Once you are happy with your skill, it's time to publish. First, package the skill into a zip file, then upload it through the Skills tab in your settings. From there, you can share the skill with your team and everyone can use it instantly. Make sure to include all necessary files, not just skill.md. Version control is key to ensuring that updates don't break existing workflows. If you need to make a small change, you can simply edit the skill and re-upload it. But if you are making structural changes like adding a new variable, creating a new version of the skill, avoid deleting live skills referenced by ongoing tasks. This could cause silent failures. So that was all about the theoretical concepts. But now we will implement those concepts into our hands-on. So let's get into that. Till now, we have been writing prompts again and again. But in real workflows, we often repeat the same task, like analyzing resumes, generating reports, or creating content. So instead of rewriting prompts every time, what if we could build a reusable command? That's exactly what a skill is. Let's build a real-world skill using Claude Cowork, an AI resume optimizer. For this, we have to write a prompt in order to create the skill. First, we will name the skill, and after that, we will give a detailed description. You can create a skill by selecting the existing skill, that is the skill creator. And after that, you can define the skill, the name, that is resume optimizer, with the description. Optimize and improve a candidate's resume based on the job role. Use when user asks to improve resume or tailor resume. Keywords should be resume improvement, resume optimization, CV review, and the job application. So let's see how that performs. Three important things are name, which becomes a slash command. Then the description. It helps AI detect when to use it. Then the keywords, which improve the trigger accuracy. You can see how the progress section has been created. It has defined first as capturing intent and understanding the requirements. Claude Cowork has prompted me to choose an option, like what should be the output. So you can choose docs file. Then the input would be resume file. What kind of optimization we are looking for? Keyword, definitely structure. I think I'll choose all of the above. After this is done, it would structure a skill.md draft for the resume optimizer. Then it will create its own test cases and run that skill.md file on those created test cases. It will also show us the output, like what kind of output you can expect when you are running those test cases with the skill and without the skill. Then if we have any kind of feedback, then we can iterate based on that. After the skill is created, it is very important that you save that in your system so that you can reuse it whenever you want. You can see how the skill.md file has been created. Now it is creating some sample test resume files to test whether the skill created is good enough or not. You can see how it is going to run evaluation with skill and without skill in parallel for all the 3 test cases. And after that, it will write the eval metadata files and spawn all 6 runs in parallel. This is the benefit of working with Claude Cowork. Like you do not have to think about the comparison. It does on its own, like in order to make sure that we are getting some good results. After it is done testing on its own, we will write some more instructions in order to structure it in a better way. If you want, you can also add like instructions like how you want the skill.md to look like. Like basically think of it like writing an SOP. You can add instructions like read the resume content provided by the user. Identify the key sections like skill, experience, projects, and education. You can also ask it to analyze the alignment with the target job role. You can ask it to suggest some improvements like adding the missing keywords, improving the bullet points, enhancing the clarity, and even generating the optimized resume content. This would allow your output to look more structured, like a step-by-step logic, clear expectations, and defined output format. This ensures consistency every time. So let's look at what it generated. You can see that the final HTML file, or basically you could say the skill, has been created. It ran some sample test and now it wants our feedback on that. So let's look at that. 2 things I want your feedback on after reviewing the outputs. Eval 0 with skill run added numbers like. You can see how the output has been generated. So you can look at that. If you want, you can add some more feedback and it will iterate accordingly. If you don't want that, you can just move and submit all reviews. So I'm going to do that. You can see that without the skill, it looks like this. I'm going to submit this one. You can just write over here, continue. You can see that now it is checking feedback.json from the eval reviewer. Since I did not add any kind of feedback, it is going to continue from where it left off. That is the issues that it mentioned, like the metric fabrication, weak ATS keyword, and the eval 0 missed SageMaker /Airflow /Spark issues. If you want, you can add some more feedback and it will iterate accordingly. You can see how it is making these changes in the skill.md file. If you want, you can just download these files and check on your own. In the earlier sections, Claude Cowork asked me some questions like what format I wanted the output in. Since I specifically asked it to provide me with the docs format, it provided me in that only. So with skill, you can see the format, but without the skill, you can see how it is providing in TXT format. You can see that the iteration has been created. These issues has been fixed and now it is creating a better version of the skill.md file. You can also make this skill dynamic. Like you can add some expected input variables like the job role, experience level, and the resume text. These variables would allow the same skill to work for different users, different roles, and different resumes. This is what makes it scalable. After it is done testing on its own created sample cases, we will be running our own test case to check how well it performs. You can see how it is checking for the keywords as well as we defined in the prompt. You can see how the skill has been tested and created. Now it is packaging the skill in a zip folder and would allow us to save that skill in our system. You can see the skill.md file it created, the overview of the skill and what it does, the basic rules it follows, and the input. If you want, you can also iterate by providing some specific or customized input variables and what would be the workflow. So you could say that it is quite detailed. So let's try testing it. First, we would be saving this as save skill. Now we'll go to manage. You can see that the skill has been created. We can use this by triggering the / command plus auto. So let's try this one. I'll use skill creator. I'll use the resume optimizer one where I'll be adding my resume. Now I'll add some job description. I'll get this one from LinkedIn. Job description. You could see over here how I'm only attaching my resume and the job description. So let's see what kind of result it provides us. Logically, it should optimize my resume according to the job description. Right now, what job description I provided requires 4 to 7 years of experience. Based on my resume, I do not have that. So let's see how it optimizes it accordingly. Also, the key skill requirements you could see in the job description I provided has basically like Python, SQL, machine learning, and deep learning, these kind of frameworks, or basically you could say the skills should be mentioned in the resume. See, even in the prompt that I provided, the description and keywords are quite strong. So even if I did not include that hash command, the skill should have been auto-triggered. This is how skill feels invisible but powerful. Also keep one very important thing in the mind. We never edit the live skill directly. Instead, we create a new version, test it, and then deploy safely. This prevents breaking existing workflows. You could see over here how it is optimizing my resume. Like first, it extracted the resume data, then passed the job description, then optimize it accordingly. You could see how it added a summary to lead with generative AI engineer and explicitly use the JD's language with keywords also. Then skill sections have been moved to the top and experience bullets strengthened with JD aligned terminology. You can also see the proficient tier expanded. You can see how good this resume looks. When it comes to ATS keywords, the projects, the skills, everything looks perfect. So let's step back. What did we actually build? We built a reusable workflow with structured logic, dynamic inputs, and consistent outputs and team-level usability with skills saved. Think about your work. How many tasks do you repeat daily? Reviewing documents, creating reports, and writing emails. All of these can become skills. To summarize, a skill allows you to define once, reuse many times, and scale across teams. You're not writing prompts anymore. You are building capabilities. Let's quickly recap what we just discussed. The key takeaways are: start with a clear name, description, and trigger for your skill. Write detailed, explicit instructions and make use of input variables to keep things flexible. Always test before publishing and use version control for safe updates. This ensures your skill is ready for your team. You have now learned how to create, test, publish, and manage your custom skills. Thanks for watching, and I'll see you in the next one. Hello, and welcome back. In the previous videos, we explored how to create skills, manage them globally or inside workspaces, and publish them for reuse. Now, we move into something even more powerful: skill chaining. Instead of using one skill at a time, we can combine multiple skills into a connected workflow, where one output naturally becomes the next input. By the end of this video, you will understand how chaining works, the three main design patterns, and how to avoid common failures. Let's begin with the core idea. Skill chaining means using a single prompt to run multiple skills in sequence. Without chaining, you usually run one skill, review the result, copy the output, paste it into another task, and repeat the process manually. With chaining, Cowork handles that entirely handoff automatically. Think of it like an assembly line. Each skill performs one job and the work moves smoothly from one step to the next. So, how does cowork actually make this possible? When skill A finishes, its output remains inside the active context window. That means skill B can immediately access what skill A just created. Your role is to clearly define what should be passed forward. And remember, the most important rule of chaining, the output of one skill should match the expected input of the next skill. A good chaining prompt usually has three parts. First, clearly state which skill should run and in what order. Second, define the handoff condition, what exactly should move from the first skill into the next one. And third, define the final output. For example, run inbox triage first, pass urgent emails into draft reply, then save all responses into one document. The first and common pattern is the sequential chain. This means skill run in a fixed order, one after another. For example, first clean the raw data, then calculate KPIs, and then generate the final report. This model works best when each step depends on the previous one. It is also the easiest to debug because if something breaks, you know exactly where it happened. The second model is the conditional chain. Here, the next skill depends on a decision. For example, after triaging emails, urgent messages go to draft reply, routine messages go to standard reply, and FYI messages go to archive. This approach is efficient because only the required skills are triggered, but it depends on accurate classification at the first step. The third model is the parallel chain. Multiple skills run on the same input at the same time, and their outputs are merged later. Imagine reviewing a contract. One skill checks the legal and another identifies deadlines, all simultaneously. This can save time, especially when tasks are independent of each other. Let's move away from content generation. Let's build something closer to a real system. Imagine you are building an AI hiring assistant. Every time a resume comes in, the system should analyze the candidates, score them, decide if they are a good fit, and generate recruiter feedback. And all of this should happen automatically. We will break this into three skills: resume analyzer, candidate scorer, and decision generator. So for that, let's go to our Claude app. You can see on the screen how the three skills has been created. Claude Cowork ran its own test on these three created skills. Some resumes were created with job descriptions, and then those resumes were tested based on the description with skills and without skills. You can see the comparison that Claude Cowork generated over here. And if you want, you can go to these created skills and look at the files it created. The description of the resume analyzer, when to use, the workflow, the text extraction, everything is according to what we prompted. Now, the most important part is to save those skills. I'll just save the skills over here. If you want, you can go to these manage buttons and see the generated skills over here. You can see the trigger command, the / command plus auto. So let's connect these three skills together now. This is not just multiple tasks. This is structured flow, data passing, and dependency between steps. You can see in step 1 how we are asking to run resume analyzer on input resume. Then the step 2, pass extracted data to candidate scorer, pass score to decision generator. After that, the final output I want is the candidate summary, score out of 10, then the decision whether it is hired or rejected with a proper reasoning. So these were some resumes that Claude Cowork generated. So I'll just select one of them. Then I'll select the job description. Now, logically, these resumes should be sent to the resume analyzer. After that, the resume and the job description will be sent to the candidate scorer, and then the step 3. Now observe. Step 1, extract structured info. Step 2, and then step 3 makes a decision. No manual intervention. You can see the resume analysis. Raj Patel, who is a rising CA senior at this college, and has 1 year of real work experience between a Bright Byte internship and an ongoing TA role. You can see the strengths and the experience that the person has. So, the first step has been completed. Now it is moving to the step 2. This system works only because of one thing: clean handoffs. You can see the output of step 1 will be handed off to the step 2. Each skill expects a specific input. If skill 1 outputs a messy data, skill 2 fails. So, output format is always equal to next input format. Now you can see the step 2 output has been generated. The score is 7.8 out of 10. Now this output becomes the input of the step 3. You can see on my screen how the three skills have been connected together. Not only it is analyzing the resume, but checking whether that person is suitable for the job description that we gave or not. After that, it is making a decision whether that person should be hired or rejected with particular reasoning. You can also extend this system by putting from resume analysis run in parallel, like generate interview questions, identify the skill gaps, and merge into the final output. Now, let's step back. We did not just change skills, we built a decision engine, a system that analyzes, evaluates, decides, and generates outputs automatically. Think about your workflows. Where do you analyze data, make decisions, and generate outputs? All of those can become skill chains. To summarize, skill chaining allows you to connect logic, automate decisions, and build real systems. You're not chaining prompts, you're building intelligence. Skill chaining is powerful, but there are common mistakes to watch for. Sometimes the output of one skill does not match what the next skill expects. Sometimes triggers overlap and multiple skills activate unexpectedly. Sometimes the handoff is too vague or there is no logic for empty results. The solution is simple. Use structured outputs, clear triggers, precise handoff instructions, and fallback rules. Now, let's quickly recap what we learned. A skill chain is one prompt that triggers multiple skills in a connected workflow. The most important principle is clean handoff. The output of one skill should fit the next skill naturally. You now know three powerful patterns: sequential, conditional, and parallel. And with thoughtful design, skill chaining can turn simple automations into complete systems. That's everything for this video. You now understand how skill chaining works, how to write chaining prompts, and how to design workflows using multiple skills together. Thanks for watching, and I'll see you in the next one. Hello and welcome to this course. In this video, we are talking about plugins, one of the most powerful and underused features inside Cowork. If you have already worked with skills and connectors, think of plugins as the next level. They do not just connect or instruct, they execute. Let's get into it. Before we define plugins, let's zoom out quickly. Cowork can be extended in three ways. Connectors extend its reach, connecting it to apps like Gmail or Notion. Skills extend its knowledge, giving it reusable task logic. And plugins extend its capabilities, adding entirely new things Cowork can actually do and run. The one-liner to remember: connectors reach, skills guide, and plugins, that word, execute, is what makes plugins different. They run actual code. Everything else flows from that. So, what exactly is a plugin? Straight from Anthropic, plugins bundle multiple MCPs, skills, and tools into a single download. One install, everything ready to go. Every plugin has four parts: a manifest file that declares its identity and permissions, tool definitions that tell Cowork what it can do, a runtime handler that actually code that runs when the plugin is invoked, and a permission scope that controls exactly what it can access. Here is my favorite way to think about it. Cowork is the project manager. It knows what needs to get done. A plugin is the specialist contractor brought in for work the project manager simply cannot do alone. Cowork directs, the plugin delivers. This is the slide I want you to really sit with. All three extend Cowork, but in completely different ways. Connectors extend reach through OAuth and API calls. Skills extend knowledge through prompt instructions. Plugins extend capabilities through sandbox code running at task time. The biggest differentiator: code. Connectors: no code needed, configured via settings. Skills: no code, written in plain language. While the plugins, yes, built with the plugin SDK. That is why plugins are built by developers or Anthropic verified publishers, not everyday users. The examples say it best: reading Gmail, which is done by connector; weekly KPI summary, the skills part; auto trimming silence from a video, that needs actual code. So that is the plugin one. Three things worth knowing before you start installing plugins. If you want to submit your own plugin, use the form at claude.com/plugins, and Anthropic handles the rest. On the review question, all community plugins go through automated checks, but the Anthropic verified badge signals an additional manual review for quality and safety. And before installing anything, use the source code link in every listing to see exactly what the plugin does and what additional software it might load. The rule of thumb: only install from developers you trust. The marketplace is browsable directly from inside the app. Customize, then plugins, then browse. 5 categories are currently active. Developer tools includes GitHub and Playwright for repository management and browser automation. Analytics and data covers PostHog and Anthropic's own data plugin for acquiring datasets and building dashboards. Design includes Figma and Anthropic's front-end design plugin for accessing design files and generating polished front-end. Productivity covers Slack and Circleback for team messaging and meeting intelligence. And code quality includes Code Review and Code Simplifier, both Anthropic verified, for automated review and code clarity workflows. New plugins are added regularly, so it is always worth checking the directory for the latest additions. Installation is 4 steps: browse, review, permissions, activate, and invoke. Simple. But that second step, reviewing permissions, is the one most people skip, and it is the most important. Before you activate any plugin, check 4 things. What file access is it requesting? Can it make network calls? Does it need audio or video access? Is it connecting to an external service? The rule is straightforward. If a plugin is asking for access it does not need to do its job, that is a red flag. A PDF plugin does not need audio access. A Slack plugin does not need file system write access. Review what is being asked and only approve what makes sense for the task. Every plugin runs in a sandbox environment, completely isolated from the rest of your system. 4 layers protect you. Permissions are declared before the plugin ever runs. Execution is sandbox and contained. Marketplace plugins with a verified badge have been reviewed by Anthropic, and everything is revocable instantly. Remove a plugin and all access is gone immediately. The mindset to carry with you: the more sensitive the access a plugin requests, the more carefully you should review it. For most well-reviewed marketplace plugins, the scope is narrow and clearly justified. So, here is the key takeaway from this video. Plugins bundle MCP, skills, and tools into one install. Every plugin has 4 parts: manifest, tool definitions, runtime handler, and permission scope. The marketplace has 5 categories with real tools ready today. Installation is 4 steps, and the permission review is the one that matters the most. Every plugin runs sandboxed with only the access you grant, revocable at any time. And the Anthropic verified badge is your strongest signal of trust. That's it for this video. You now know what plugins are and how they differ from connectors and skills, how to install and use them safely. Thank you, and I'll see you in the next one. Hello and welcome back. In this video, we go into creative workflows with Adobe AI tools, one of the most powerful plugins in the Cowork marketplace for anyone working with visual content at scale. By the end of this video, you will have the plugin installed, connected to Creative Cloud, and running real creative tasks entirely through Cowork prompts. Before we install anything, let's understand what this plugin actually unlocks. Without it, creative tasks require switching between Cowork and Photoshop or Premiere, exporting files, importing results, and repeating that loop for every asset. With the Adobe plugin, Cowork can call Creative Cloud's AI capabilities, directly batch editing photos, resizing assets for multiple platforms, applying templates, and even generating highlight edits from video, all from a single task prompt. Installation follows the same 3-step flow as every plugin in Cowork. Go to Customize, then Plugins, then Browse. Search for Adobe under the Anthropic and Partners section. Click Install, and OAuth window will open, prompting you to sign into your Adobe account. This is what grants Cowork access to your Creative Cloud files and AI tools. Once you approve, the plugin goes active immediately. Run the confirmation prompt on screen to verify the connection before starting any creative task. Here is everything the Adobe plugin can do inside Cowork. Batch photo editing lets you apply the same style, color grade, or tone adjustment across an entire folder of images at once. Social media asset creation handles sizing and formatting for every platform from a single source file. Template-based design pulls your existing Creative Cloud templates and populates them with the new content. Resizing outputs the same asset in exact pixel dimensions for every channel you need. Video highlight editing auto-selects and assembles the best moments from longer footage. And portrait retouching applies consistent corrections across batches of headshots or product images. Most people think creative work means opening Photoshop, Premiere Pro, or Canva and manually designing things. But today, I'm going to show you a completely different approach. Instead of doing the work, you will learn how to direct the work using AI. We are going to use Adobe's AI-powered tools not as individual features, but as a complete creative system. By the end of this hands-on, you will be able to edit multiple photos in seconds, create social media assets for all platforms, design professional visuals without design skills, turn raw video into highlights, and most importantly, build a repeatable workflow. For this, let's go to our Claude Cowork. First, you have to go to the Customize section. Then, you can search for plugins over here, Browse Plugins. Go to this section. Then from here, you can install the Adobe for Creativity, which we will be using for this hands-on. I've already added it in my Claude Cowork. Once this is added, you can go to the settings. You can customize your photos, visuals according to your own brand guidelines. So let's get into that. We'll go back to our chart. Before you start creating anything, this is the smartest step. You're telling the AI how your brand looks, the colors, tone, and the style. Think of this like setting up your design system. We are asking Claude Cowork to customize the Adobe for Creativity plugin for my company. Use a white and blue color theme, clean modern design with a minimal layout. Optimize outputs for LinkedIn content, educational posts, and AI-related visuals. Ensure all designs follow a professional and consistent brand styles. So over here, you can see that it has opened the Claude plugin folder, and now it will be creating the skill.md file for these particular styles. If you skip this, every output will look different. If you do this properly, everything will look consistent automatically. Now notice over here, what is happening in the background. The AI is not just answering, it is actually inspecting the plugin. It is reading all the skills one by one. Design, social variation, batch editing, retouching, and the video editing. Now, it is figuring out where do I inject brand consistency. This is very important. It is not blindly applying the changes. It is analyzing the structure, then planning modifications, and then applying them. This is what makes these systems powerful. They understand context and not just commands. Now, look at this. This is not a simple output. It has customized all 6 skills. Let me break this down for you in simple terms. Design skills now defaults to LinkedIn style post. Social variation prioritizes the LinkedIn format. Batch editing uses cool white blue tones instead of warm filters. Retouch gives professional headshots and not just Instagram filters. While the video focuses on educational clips and not entertainment edits. This is how you turn AI from a tool into a system. You can see on my screen how the plugin has been created. Now, in order to make use of it in our future projects, we need to save the plugin to our project directory. After it is saved, we can prompt the model in the same chat in order to create some LinkedIn post. You can see I have prompted the model, create a LinkedIn post design for an AI course using my brand style. Notice something important here. I'm not specifying colors again. I'm not saying white and blue. I'm not saying clean minimal layout because the system should already remember that from the customization step. This is the difference between prompting every single time versus building reusable AI systems. Now, you can see the AI has started processing the request, and this part is very important to observe carefully. Most people think AI instantly generates designs, but actually it performs multiple orchestration steps in the background. Notice this line, used a skill. This means Claude is not responding from memory. It is activating a specialized capability from the plugin. This is where AI agents become different from the normal chatbot. A chatbot gets text and AI workflow execute tools. Now, Claude is initializing Adobe. This means it is preparing the creative environment before generating anything. And look at the next part. It is searching for LinkedIn templates that match my brand style. This is huge. The AI is not randomly generating visuals. It is trying to match platform, brand style, design intent, and business context. This is contextual AI, not generic AI. Now, it says it ran multiple commands in the background. The AI is accessing tools, checking integrations, reading plugin configurations, and preparing design operations. This is exactly how modern AI systems work internally. Now, this is actually a very valuable moment because in real AI workflows, things fail. And knowing how to handle failures professionally is important. Claude is telling us the plugin exists, the customization exists, but the connector is not authenticated yet. This is not an AI failure, this is an infrastructure dependencies. Most AI workflow issues are not intelligence problems, they are integration problems. So, now notice how clearly the AI agent explains the recovery process. It tells us exactly what to do, save the plugin, restart Cowork, connect Adobe, and return to continue. So I did just that. Over here, you can see the Canva has been connected, but Adobe for Creativity still hasn't been connected. This is good AI UX. The system is not just failing, it is guiding the user toward resolution. Now, this line is extremely important. The entire workflow runs inside the conversation. This is where interfaces are evolving. Instead of switching between Photoshop, Canva, Figma, Drive, and email, the conversation itself becomes the operating system. So, After connecting, I tried to attempt it for the second time. You can see I've prompted the model again. And notice something powerful here. Claude already remembers the white and blue branding, the clean layouts, and LinkedIn first design. This is persistent workflow memory. Now, this is exactly what we wanted. You can see how it shows that Adobe for Creativity Connector isn't active in the session yet. But Canva connected, we can create your branded LinkedIn post design right now using that same brand style. The AI confirms that the brand configuration has been loaded successfully. This means our customization worked. We successfully modified the behavior of the plugin. Now, even though Adobe isn't connected, watch what happens next. Claude intelligently falls back to Canva because it detects Canva is available. This is adaptive orchestration. The AI is dynamically choosing available tools to complete the task. Good AI systems don't stop at failure, they reroute. Now, we are getting actual outputs as you can see on my screen. And look carefully at the consistency. Even though Adobe wasn't connected, the outputs still follow. White and blue branding, minimal layouts, and professional LinkedIn styling, which proves the customization instruction persisted across the workflow. Another important concept, the AI is not giving one answer, it is generating multiple creative directions as you can see on my screen. Option 1, option 2, it gave us 4 options in total. This is how professional creative workflows operate. Instead of asking, is this correct? You ask which direction do we want to pursue. Now, the AI moves into collaborative mode. It generated options. Now it asks for feedback before finalizing. This is the future of human AI collaboration. AI generates possibilities, human makes decisions. If you want, you can choose either of these options and iterate accordingly. What you just saw was not simply image generation. You saw plugin customization, workflow memory, tool orchestration, connector management, adaptive fallback systems, and collaborative creative generation. The future of AI is orchestrated systems working together through conversation. So let's get back to our slides now. Before you start using the plugin for real work, it is worth understanding exactly what you are granting access to local file. Local file access covers only the folders you specify. Cowork reads inputs from those folders and writes exports to your designated output path. Creative Cloud Access lets the plugin read your templates, presets, and assets, but it does not touch your Adobe account settings or the billing. Media processing means the plugin analyzes and edits your files for the duration of the task. No data is retained after that task completes. And all of this is revocable at any time from your plugin setting. So, here is the key takeaway from this video. The Adobe plugin is one of the most capable in the marketplace for creative teams. It brings 6 distinct Creative Cloud AI capabilities into Cowork without any app switching. Installation is a single OAuth flow. All 6 capabilities are triggered through plain English prompts, and permissions are always scoped and revocable. In the next video, we'll look at building a custom plugin from scratch for when the marketplace does not have exactly what your workflow needs. See you there. That's it for this video. You now have the Adobe plugin installed, connected, and running real creative tasks inside Cowork. Batch editing, social assets, resizing, highlight reels, all from a single prompt. Thank you, and I'll see you in the next one. Hello, and welcome back. In this video, we work with 2 design tools inside Cowork, but they connect in different ways. Canva comes in as a connector specifically through the Canva MCP server, which is Canva's official model context protocol implementation. It gives Cowork secure, structured access to your Canva account, your designs, templates, and brand kit, all through MCP. No code involved. Figma comes in as a plugin, a code-level runtime extension that can design, extract, and export from your design files directly. Understanding that difference matters because it changes how you set them up and what they can do. Let's go through both. Before we install anything, let's understand how each tool actually connects to Cowork because they work differently. Canva is a connector. It connects through the Canva MCP server. This gives Cowork secure access to your designs, templates, and brand kit through MCP. No code, no manual transfers. Figma is a plugin. It does not just export, it can also create and design at runtime. It accesses your Figma files, generates designs, extracts frames and components, and export assets, all through sandbox code execution. Same outcome for your workflow, design assets without switching apps. But Canva communicates through MCP, while Figma executes code to both design and deliver. That difference determines how you set them up and how Cowork invokes each one. The setup paths are different, and that is intentional. For Canva, go to Customize, then Connectors and not Plugins. Search for Canva, click Connect and sign in via O authorization. You're granting Cowork access to your Canva brand kit and templates through the Canva MCP server. This is how Cowork communicates with your Canva account securely without you sharing credentials directly. For Figma, go to Customize and Plugins because Figma is a code level plugin and not a connector. Search for Figma, click Install, and sign in to grant file read and export permissions. Once both are set up, run the 2 test prompts to confirm each connection is live before starting any real task. Here is the first demo. You have a brand brief, specific hex colors, a headline, and a platform format. You reference the Canva connector in your prompt, specify the template, the brand colors, and the output path. Cowork communicates with Canva through the MCP server, selects your standard template, applies the colors, inserts the headline, and exports the finished graphic to your folder. Because Canva is an MCP connector, everything happens through the Canva MCP server directly. No app switching, no manual export step. Now, let's go through the demo 2 first, and then we will integrate both demo 1 and demo 2 in our hands-on experiment. In the second demo, you can ask Cowork to customize the Figma plugin specifically for your company, and all it takes is one prompt. Type customize the Figma plugin for me and based on my company. And Cowork will ask you a few targeted questions: your brand colors, your typography preferences, your design standards, and which Figma file or team library to reference. Once you have provided those details, Cowork sets them as default parameters inside the plugin. Every Figma task you run after that automatically applies your brand guidelines. No need to specify them again in every prompt. Let's set this up now before we move into the demo. So let's get into it. You can go to the Customize section, and over here you can go to the connectors. You can click and find the Canva over here. I have already installed it on my Claude Cowork. You can install it from here. After that, you can go to the plugin section, Anthropic and Partners. From here, you can install the Figma one. I've installed both in my Claude Cowork, so we'll get started on the hands-on task. I'll go back to my chat. You can see on my screen how I prompted both the demo 1 and demo 2 together in one single prompt. It's your choice. You can iterate accordingly or basically prompt the model in 2 different chats. So basically in this section, we will combine Canva for fast branded content generation and Figma for structured product design workflows. This is where AI stops being just a content assistant and starts becoming part of your design operations. Here you can see what I have prompted the model. Use Canva connector to create a LinkedIn post graphic using our brand colors, and the headline should be 5 ways AI changing how teams work. Use our standard post template. With that, I have also attached customize the Figma plugin for me based on my company. Now, this is extremely important. Notice how Claude says, I'll tackle both the tasks simultaneously. This means the AI is running workflows in parallel. Instead of doing task 1 and then task 2, it is orchestrating multiple operations together. This is how AI agents behave differently from traditional software. Notice it is accessing multiple systems in the background. It is checking Canva assets, reading available templates, loading brand information, and preparing the design workflow. This orchestration layer is what makes enterprise AI powerful. Now, here is another realistic scenario. The AI checks for an existing brand kit, but none exist. Over here, you can also see how it asked me certain details about my company brand guidelines so that it can customize the Figma plugin accordingly. And this is important. AI system must handle incomplete environments gracefully. Instead of stopping, Claude adapts according to what I have prompted or basically what I have chosen from the options it gave me. Now, after I chose, it said that let me generate the Canva post and read the Figma plugin files in parallel. You can see over here now, after we have moved from orchestration to creative generation, and notice something important. It did not generate one option. It generated multiple creative directions. This mirrors real agency workflows. Design is not about finding one correct answer. It's about exploring the possibilities, like how it gave me certain options and not just one design. And you can notice the consistency across all options. Cut. Navy and gold branding, clean typography, professional layout, and LinkedIn first composition. This consistency comes from the system configuration we defined earlier. Now, after the designs have been generated, let's see how it customizes the Figma plugin. You can see over here, now it is focusing on the Figma plugin. The Claude shifts into discovery mode. Before customizing the Figma plugin, it gathers the organizational context. Because design systems are not just visuals, they include frameworks, component architecture, file structures, and engineering standards. Now, using these questions, we are giving the AI technical context. This is critical because design systems must align with your engineering systems. AI becomes dramatically more useful when it understands your stack. Now, using this folder structure, we are giving the AI project structure awareness. Instead of generic outputs, the AI now understands where components belong inside the code base. This is the moment where actual customization happens. Claude is modifying the plugin configuration itself. It is embedding the tokens. You can see how it is embedding the brand tokens, Tailwind defaults, component rules, and design system behaviors. You can open any of these files and check the code for your reference. We are no longer prompting manually, we are changing the system's default behavior. Now, you can see the plugin is being packaged with all customizations applied. This effectively turns the plugin into a company-specific design system. Everything is now standardized React plus Tailwind, custom components, SRC components, Navy and Golden tokens. This means future outputs automatically follow company standards. Now that the design is configured, let's actually build something with it. We'll focus this on our demo 3. The third demo uses the Figma plugin, and notice the difference in how it works compared to Canva. The Figma plugin executes code at runtime to read the file structure, identify every frame, export each one at 2x resolution, and save it with the frame name as the file name. This is a code-level operation, something that could not be done through a simple API call. This is exactly why Figma is a plugin rather than a connector. For the developer receiving these files, the output is exactly what they need with zero manual export work. So let's see how to get this done. I'll prompt the model. Use the Figma Power plugin that we created above to create a simple mobile app onboarding design with 3 screens for an AI productivity app. Include a welcome screen, feature highlight screen, and sign up screen using a modern blue and white theme. If you want, you can just use the plugin that we created earlier, then export all frames as PNGs at 2x resolution and save them to a particular file or the folder using the frame names as file names. You can see over here how Claude loads multiple skills together. This means the workflow is composable. Different AI capabilities can cooperate inside one task. You can see both the skills have been loaded. But now Claude detects an important dependency, that is Playwright. Figma requires a workspace or file context. This shows the AI understands environment requirements and not just the prompts. You can see how it is showing that Playwright is available. I'll build the 3 onboarding screens as high-fidelity HTML mockups. Since direct Figma writing is not available, Claude intelligently switches to a fallback workflow using Playwright. This is adaptive execution. The goal stays the same, deliver onboarding screens. But the implementation path changes. Instead of waiting for Figma integration, the AI generates production quality HTML mockups. This is important. Modern AI workflows are outcome-oriented, not tool-dependent. Now, the AI is generating each onboarding screen individually. This includes layout, typography, spacing, CTA buttons, gradients, and onboarding structure. It's applying the design system automatically. Now it moves into asset production. You can see how it is exporting these screens. You can preview them over here. You can look at the level of detail. Claude describes gradients, onboarding flow, feature cards, progress indicators, and CTA hierarchy. This is not just image generation, this is structured UI generation. Now Claude explains the next level capability. If the Figma MCP server is connected, it can directly write frames, components, variables, and auto layouts into Figma, or you could directly export them into the Figma app. This is where AI becomes deeply integrated into professional product design workflows. What you saw here was not just Canva automation and not just Figma exports. You saw AI-powered design systems, multi-tool orchestration, adaptive workflows, automated asset production, and developer-ready handoff pipelines. The future of design is not human versus AI. It's human building systems where AI handles execution at scale. Now, this is one of the another demo that you can experiment with. This is where the Canva connector becomes genuinely powerful when combined with the file system. Instead of copying campaign copy into Canva manually, you point Cowork at the brief document and instruct it to generate 5 variations via the Canva connector. Cowork reads the file, extracts a copy, calls the Canva API with your brand template, and produces 5 distinct social card layouts saved to the right folder. The connector handles the calls, the file system handles the document reading, one prompt connects them both. This distinction matters. Cowork through the Canva connector is extremely good at execution, creating branded graphics, generating variations, resizing assets across platforms. The Figma plugin handles bulk exports and frame extraction without any manual work. What neither can replace is the original creative judgment, the concept, the art direction, the fine-tuning of visual hierarchy, the strategic decisions about what a campaign should feel like. Cowork accelerates the production layer. The creative vision still comes from the designer. So, here is the key takeaway from this video. Canva connects via MCP server, set it up through connectors, not plugins. Figma is a plugin, set it up through plugins. You can customize the Figma plugin to your brand with a single prompt. Cowork applies your colors, fonts, and design standards as defaults for every subsequent task. Both are triggered through plain English. Combine the Canva connector with the file system for document to design workflows. And the creative direction still needs a human. Cowork handles execution, not vision. That's it for this video. You now have the Canva connector and the Figma plugin set up and running inside Cowork. And you understand why each one connects the way it does. Thank you, and I'll see you in the next one. Hello and welcome back. In this video, we will go through the plugin SDK, understand what every plugin is made of, and build one from scratch, live. Before writing any code, it is worth asking, do I actually need a custom plugin? If a marketplace plugin handles the task, use that. If an MCP connector can call the API you need, use that. A custom plugin makes sense in three specific scenarios. First, when a company has internal tools or APIs that are simply not in the marketplace. Second, when the processing logic is proprietary and cannot be exposed through a public plugin. And third, when a task repeats constantly but no existing plugin handles it the exact way your workflow requires. If you have explored both connectors and skills and still have a gap, that is your signal to build. Every Cowork plugin, whether from the marketplace or built by you, is made of same four parts. The manifest file declares the plugin's identity and tells Cowork what permissions it needs. The tool definitions tell Cowork what the plugin can be called, for this is what gets matched against the task during execution. The schema defines the exact shape of data going in and coming out. Cowork needs this to pass the right inputs and read the right outputs. And the runtime handler is the actual code that runs when Cowork invokes the plugin. Together, these four files make a complete invocable plugin. Here is what we are building. The PDF watermarker plugin takes a PDF file, a logo image, a position preference, stamps the logo on every page, and saves the watermarked output to a specified folder. It is a simple but genuinely useful plugin. Every company that produces branded documents needs this kind of stamping at some point, and it is not available out of the box in Cowork. By the end of this video, you will have a working version of this plugin running locally. Here are the four files that make up the PDF watermarker plugin. The manifest declares the name and the two permissions it needs, file read and file write. The tool definition gives the plugin a name, a human-readable description, and the trigger keywords Cowork uses to match it to relevant tasks. The input schema defines the four things Cowork must pass in: the PDF path, the logo path, the position, and the output path. And the handler is the Python function that does the actual work: open the PDF, overlay the logo on every page, and save the result. The full implementation goes in the handler, and we will fill that in during the live build. Never publish a plugin without testing it in all three phases. First, unit test. The handler in isolation run it directly with the sample file and confirm the output is correct before Cowork is involved at all. Second, load it into Cowork in local mode. Go to Customize and Plugins, then load local plugin and point it at your plugin folder. Run the test prompt on screen and confirm Cowork involves the plugin correctly and passes the right inputs. Third, test edge cases. What happens if the PDF is password protected? What happens if the logo path is wrong? Your handler should flag these cleanly rather than failing silently. Once your plugin is tested and working locally, submitting it to the marketplace is a four-step process. First, zip the entire plugin folder, all four files together. Second, go to the Anthropic developer portal, find the submit plugin form, upload the zip, and fill in the display name, category, and description. Third, Anthropic's review team checks three things: that the permissions you declared in the manifest match what the code actually uses, that the schema is accurate, and that the handler does not contain anything unsafe. Fourth, once approved, your plugin appears in the marketplace. The review typically takes 5 to 10 business days and you will receive email updates at each stage. So for this hands-on, you have to go to the Claude Cowork, then click on the Customize. Since we are creating a new plugin, you can also use / plugin creator that we already have in a directory. So now we'll build a custom Cowork plugin called PDF Watermarker. This plugin will automatically stamp a logo watermark on every page of a PDF. So let's go to our Claude Cowork. Over here, you can see I've given the Claude Cowork a prompt. Every Cowork plugin starts with a plugin workspace. Cowork automatically creates a plugin folder structure for us. Inside the Cowork chat, we have pasted a prompt. Create a custom Cowork plugin called PDF Watermarker. The plugin should stamp a logo watermark on every page of a PDF, except PDF file path, logo, image path, watermark position, output folder. Save the final branded PDF automatically. Then generate the plugin.json, tools.json schema definition. Use Python for the runtime handler. Instead of manually coding everything, we use Claude to generate the plugin structure automatically. You can see how it generated the plugin.json file, tools.json file, and schema.json. These are the 4 code parts of every Cowork plugin: manifest file, tool definition, input schema, and the runtime handler. First, let's look at plugin.json. This manifest registers the plugin with Cowork and declares the permissions. Now, let's look at the tools.json. You can see how different tools are defined with different properties. This defines the tool Cowork can invoke during the task. The schema basically defines what the inputs the plugin expects from the user or workflow. Now, let's go to the handler. This Python runtime contains the actual watermarking logic. We have received a PDF, but now how do I input that particular logo onto the PDF? You can see how the files have been created. The plugin has been generated. Now we'll save the plugin. We are basically saving the plugin for our future use. Now in order to run locally, you can directly call plugin from here, PDF Watermarker. As you can see, I have selected the watermark PDF. Now you can directly input your PDF file and it will give you a PDF logo. You can see after calling the plugin, you can directly input your PDF file and the output will be generated. Before publishing, always test locally to verify the watermark appears correctly. After testing, we package the plugin and submit it for marketplace review. This plugin can now be reused in automated workflows for branding documents at scale. Now let's go back to our slides. Here's a range of what teams actually build custom plugins for. Internal CRM connectors for proprietary databases that have no public API. Custom report generators that format output to exact company templates. Compliance checkers that validate documents against internal policies before they leave the organization. Brand asset stampers like the one we just built. Watermarking, logo stamping, or appending footers to any file type at scale. And legacy system bridges for older internal tools that predate modern APIs. The pattern across all of them is the same: a manual step that repeats frequently enough to justify one-time build. So, here is the key takeaway from this video. Build a custom plugin when the marketplace cannot fill your specific capability gap. Every plugin follows the same 4-file structure: manifest, tool, schema, and handler. Always test locally in all 3 phases before you submit. The review process checks that your declared permissions match your actual code. And the best use cases are always the same: internal tools, proprietary logic, and workflows that repeat often enough to justify a one-time build. That wraps up the entire plugin series. In the next module, we move into Claude Dispatch. That's it for this video. You now have the complete picture of how to extend Cowork at every level. Connectors for API, skills for prompt logic, and plugins for runtime capabilities. Thank you, and I'll see you in the next one. Hello, and welcome back. In this video, we will understand a feature inside Cowork that lets you assign tasks to Claude from your phone, and Claude runs them on your laptop while you are away. Your phone becomes a remote control for your AI agent. Let's understand exactly how it works. We have covered skills and connectors in this Cowork course. Each makes Claude more useful at your desk. None of them solves the obvious problem: you have to be at your desk. Dispatch fixes that. Before Dispatch, you had to be sitting at your desk to use Cowork. Now you can assign tasks from anywhere, during your commute, from a coffee shop, or while running errands. When you return to your computer, the work is already done. In Claude Cowork, Dispatch is the ability to kick off a task with Claude from your phone that keeps running on your computer. Send Claude a task from the mobile app wherever you are. Claude does the work on your computer with your files, your browser, the apps you have installed, and replies when it's done. Think of it as a walkie-talkie to your cowork session. You speak from your phone, the work happens on your computer. Dispatch turns your phone into a remote control for Claude on your computer. You send a message from the Claude mobile app, and the Claude runs the task on your machine, reading local files, pulling data through connectors, searching the web, and compiling results. When you get back to your desk, the work is done and waiting. The one hard requirement is that your computer must be awake and running the Claude desktop app, which is why Dispatch has a keep awake toggle built into the setup. From your phone, you can now access everything on your desktop through Claude, including files, connectors, any plugins you have installed, and your apps through computer use. This is the full power of your Cowork setup, now accessible remotely. Anything that you could do on the desktop app can now also be triggered from your phone. In Claude Desktop, navigate to the Cowork tab and click Dispatch in the left panel. Select Get Started and you will see two toggle options, File Access and Keep Awake. Toggle the options you need and click Finish Setup. A QR code appears on your desktop screen. Open the Claude app on your phone and scan it. Once paired, a conversation thread appears in the Dispatch section on both devices. That is it. Start typing on your phone and Claude gets to work on your desktop. From your phone, you can handle Claude tasks that use everything on your desktop, including things you can't open on your phone. Ask Claude to pull data from a local spreadsheet and compile a summary report. Have Claude search your Slack messages and email. Then draft a briefing document. Request a formatted presentation built from files in your Google Drive. Tell Claude to organize or process files in a specific folder on your computer. And any dispatch task can become a scheduled task that runs on a cadence. Set it once and Claude runs it automatically. In Claude Cowork, Claude can now enable computer use to complete tasks. When Claude does not have access to the tools it needs, it will point, click, and navigate what is on your screen to perform the task itself. It can open files, use the browser, and run DevTools automatically. But this is optional. Computer use stays off unless you choose it. Dispatch still works without it. Claude just won't reach into apps that need cursor and keyboard control. And one practical reminder before you walk away from your desk, keep your computer awake. If it goes to sleep, Claude stops working. Use the Keep Awake toggle in Dispatch settings. Adjust your system sleep settings before you leave. This capability is available in beta for Pro and Max plans on Claude Cowork. It requires both the Claude desktop app and the Claude mobile app. On current limitations, as a research preview, Dispatch has some constraints worth knowing. Desktop must stay awake. Single conversation thread only. Everything runs through one persistent conversation. No push notifications. You will need to open the app to check on results. Tasks that involve reading and analyzing files work very reliably. Complex actions like controlling third-party apps are improving but can occasionally be unstable. So, here is the key takeaway from this video. Dispatch is not a model selection tool. It is a mobile to desktop bridge. One conversation thread runs across both devices. Claude has access to everything on your desktop during a dispatch task. Setup is 3 steps and takes under 2 minutes. Any task can be scheduled to run automatically. And Keep Awake toggle is essential. Without it, your computer sleeps and the task stops. That's it for this video. You now know exactly what Claude Dispatch is, a mobile to desktop bridge that lets you assign tasks from your phone and come back to finished work on your computer. It is not a model router. It is not a task classifier. It is a remote control for your cowork session. Thank you, and I'll see you in the next one. Hello, and welcome back. In this video, we make it concrete with 6 real-world use cases, from long research tasks to overnight automations to full desktop control. By the end, you will know exactly when to reach for dispatch and how to get the most out of it in each scenario. Before we go into use cases, a quick grounding. Dispatch is not a chatbot on your phone. It is remote task delegation. You send an instruction from your phone. Claude executes it on your desktop with full access to your local files, connectors, and apps, and it messages you when it is done. The 3 things that make it different from a regular conversation. Mobile to desktop execution, one persistent thread that carries context across every task, and asynchronous completion. You are not waiting for a response. You are doing something else while Claude works. 6 use cases. Each one represents a different category of work where dispatch gives you a genuine advantage over sitting at your desk. We will go through each one with a real example prompt so you can see exactly what to type and what to expect back. Let's go. The first use case is research. Long research tasks are perfect for dispatch because they take time, they do not require you to be present, and the output file is you can review when you are ready. You send the prompt before your first meeting. Claude reads your internal documents, searches the web for competitor information, synthesizes the findings, and saves the report. By the time your meetings are done, the analysis is waiting in your folder. No switching between tasks, no losing your train of thought. You delegated the heavy lifting before it even started. So let's try this prompt on our dispatch. Here, I'm demonstrating how Claude can handle long-running research workflows asynchronously through Cowork. In this scenario, I need a competitive analysis across multiple company websites, recent press releases, but instead of manually doing all the research, I dispatch the task and let Claude continue working while I am away or in meetings. What is important here is that Claude is not just answering a single prompt, it is actually coordinating multiple actions across documents, web browsing, synthesis, and file management. While the task is running, Claude keeps working independently on the computer. It accesses local files, searches external sources, synthesizes findings, and saves the final output automatically. You will also notice permission handling in action. When Claude needed access to a folder, it paused and requested approval before continuing. This keeps the workflow secure while still enabling autonomous execution. This is a strong example of asynchronous AI work, where the user can dispatch a complex task and let Claude complete the workflow end-to-end in the background. Use case 2 is overnight automations. Any dispatch task can be turned into a recurring scheduled task with a single line. In this example, you run the weekly briefing task once, confirm the output is what you want, then tell Claude to run it every Monday at 6 a.m. From that point on, your weekly briefing compiles itself. Email, Slack, calendar, metrics, and that document is sitting on your desktop before you even make your coffee. This is where dispatch transitions from a convenience feature to a genuine autonomous workflow. File organization is one of the most satisfying dispatch use cases because the result is so immediate and visible. You are out of the office, you remember your downloads folder needs sorting before a meeting. You send one output from your phone. Claude reads every file, creates the right subfolders by client name, moves and renames everything to your specified format, and logs every change so you can audit it. You arrive at your desk to a clean, structured folder. No manual dragging, no forgetting which files belong where. So let's try performing this on a dispatch from our mobile. In this hands-on example, I'm showing how Claude can help automate messy file organization tasks remotely through Cowork. This scenario here is very practical. Instead of manually sorting hundreds of files, I dispatch a structured instruction to Claude. What makes this useful is that Claude is operating like a digital operation assistant rather than a chatbot. It understands folder structures, applies formatting rules consistently, and maintains traceability through logging. This is especially valuable for teams handling large volumes of documents, client deliverables, or operational workflows where manual organization becomes repetitive and error-prone. The key takeaway from this demo is that Cowork enables Claude to perform real desktop-level workflow automation and not just text generation. Use case 4 is content creation while traveling. This is the scenario that makes dispatch genuinely powerful for anyone in creative or marketing role. You are on a flight, you send 3 prompts before your phone goes into airplane mode. Claude writes the LinkedIn post from your content brief, builds the client deck from the project brief, and generates 5 Canva social cards using the Canva connector. 3 separate content workflows running in parallel on your desktop. When you land, you open your laptop and 3 finished files are waiting for your review. What would have taken 2 hours of focused desk time is done before you reach your destination. So let's try performing this all at once. The final use case demonstrates how Claude can orchestrate multiple creative and productivity workflows in parallel while the user is away or traveling. In this example, I dispatched 3 separate tasks simultaneously. The idea here is that while I'm traveling or offline, Claude continues executing all these workflows independently on my computer. One task is for LinkedIn, another for client presentation, and another for Canva workflow. What is especially powerful here is the orchestration capability. All 3 workflows are running in parallel: content writing, presentation generation, and design asset creation, without continuous human supervision. You can also see how Claude provides live progress updates. At the end, everything is generated and organized automatically. The LinkedIn post is saved, the PowerPoint deck is ready, and the Canva assets are created and linked. This demonstrates how Cowork transforms Claude from a conversational assistant into an autonomous execution agent capable of handling end-to-end creative operations. Use case 5 is continuing active projects. The power of persistent context. Because dispatch uses one continuous thread, Claude retains full context from previous tasks in the same project. You do not re-explain, you just continue. The example thread would be this one: on Monday, EV charging sector, and then save the progress. But on Tuesday, you continue with it by saying, continue the EV research report, add a section on a particular regulatory changes in Europe. Then you continue that on Wednesday evening. Finalize the EV report and create an executive summary. Email the draft to me. One report built across the 3 sessions. 2 devices, 0 re-explaining. The final use case is the most powerful dispatch combined with computer use. Without computer use, Claude is limited to connectors, files, and the web. With computer use enabled, Claude can open any app on your desktop, make edits directly, and navigate tools that have no connector or API. In this example, a client needs a figure updated in a document. You are away from your desk, you send one prompt, Claude opens the document, changes the figure, exports to PDF, and attaches it to your calendar invite. The full task is done without you touching your computer, and the reminder applies here especially. Your desktop must stay awake for computer use tasks to complete. Under the hood, Dispatch has 3 layers working together. The first is orchestration. Your mobile message is received by the Claude desktop session, which passes the intent and identifies which tools are needed. The second is the persistent session. The thread stays alive across all messages and both devices for as long as your desktop is away. The third is asynchronous execution. Claude works in the background and you are not tied to the conversation. You close your phone, Claude keeps going, and the result lands in the thread when the task is complete. This 3-layer architecture is what makes Dispatch feel different from a regular chat. It is delegation and not just conversation. Setup is 4 steps and takes under 2 minutes. Open Dispatch from the left sidebar. Toggle on file access and critically toggle on keep awake before you leave your desk. Without keep awake, your computer sleeps and the task stops mid-execution. Scan the QR code with your phone and the devices are paired. Once paired, they stay connected. You do not need to rescan for future sessions. And for managing active sessions, you can view running tasks in the thread on either device, cancel a task by replying stop, and review the full log of completed tasks in the same persistent thread. So, here is the key takeaway from this video. Dispatch is delegation, not conversation. Long research tasks are its strongest early use case. High value, low risk. The scheduling capability transforms Dispatch from a convenience into a genuine autonomous workflow system. File management, content creation, and project continuation all work reliably today. Combined with computer use for tasks that require interacting with apps directly. And the most important practical reminder, keep your computer away. Everything else in this list depends on that one setting. That is everything for this video. 6 use cases, each with a real prompt you can use today. Research tasks, overnight automations, file organization, content creation while traveling, continuing active projects, and full desktop automation with computer use. Thank you, and I'll see you in the next. Hello, and welcome back. In this video, we go deep into configuration, how to control what runs autonomously, how to handle failures and disconnections, how to get notified at the right moment, and how to build multi-stage workflows that chain themselves together. By the end, you will have a fully configured autonomous workflow running from your phone. Here is everything we are configuring. Smart interruptions. So, Dispatch knows when to ask for approval and when to just get on with it. Remote recovery. So your workflows survive disconnections and unexpected app closures. Notification workflows. So your phone tells you what matters when it happens. Multi-stage workflows. So one completed task automatically kicks off the next without you sending another prompt. Execution telemetry. So you can monitor what is actually running. And concurrent job management. So you can run multiple workflows simultaneously without them stepping on each other. Smart interruption handling is the most important configuration decision you make. The rule of thumb is simple. Anything irreversible or externally visible should require your approval. Sending an email, posting content, deleting a file, these needs a pause and a check. Everything that is local, reversible, and contained, reading, analyzing, drafting, searching, can run autonomously without interrupting you. You define these boundaries directly in your task prompt. Claude reads the instruction and respects it for the duration of the workflow. Get this right and you get the best of both worlds. Speed where it is safe, control where it matters. Remote recovery is what separates a reliable autonomous workflow from a fragile one. 3 scenarios to design for. If a task fails mid-execution, you want Claude to save partial progress and tell you exactly where it stopped, not silently fail and leave you with no output. If your desktop disconnects or sleeps, the task should pause at a safe checkpoint and resume when the connection restores. And if an application closes unexpectedly during a computer use task, Claude should stop. Log the state and wait for your explicit instruction before attempting anything further. Building recovery instructions into your prompt is the simplest way to configure this behavior. Notification workflows determine when and how your phone gets updated during a running dispatch task. 4 moments matter. Task completion, always. Approval request, immediately with a specific question so you can reply yes or no without needing to know the full context. Execution failures, immediately with enough information to make a decision. And progress updates for long tasks. A 30-minute check-in on a multi-hour workflow means you always know it is still running and still on track. Configure these directly in your task prompt and Claude respects them for the entire execution. Multi-stage workflows are where dispatch becomes genuinely autonomous. Instead of sending a new prompt for each step, you define the full chain upfront and Claude executes each stage in sequence, automatically triggering the next when the previous one completes. In this example, research runs fast and saves findings to a file. When that is done, Claude uses those findings to generate a LinkedIn post and social cards via the Canva connector. When that is done, it organizes all outputs into the project folder and sends you a summary. 3 stages, 1 prompt, no interruptions from you unless an approval trigger fires. Execution telemetry gives you visibility into what is happening on your desktop while you are away. The dispatch thread updates in real time. You can see which stage is running, which tools are active, and which files are being touched, and how long the task has been running. At any point, you can reply status in the thread to get a plain language progress summary without interrupting the execution. This is particularly useful for long-running or multi-stage workflows where you want to confirm things are on track without waiting for a completion notification. As you get more comfortable with dispatch, you will naturally start running multiple workflows simultaneously. Research in the background, file organization completing, content generation starting, all at once. The key to keeping this clean is keeping tasks independent. 2 tasks writing to the same folder at the same time creates conflicts. Separate output paths, clear task labels, and explicit priority signals keep concurrent workflows running smoothly. And one status message in the thread shows you the state of all active tasks at once. You do not need to check each one individually. Enterprise-style reliability comes down to 4 principles. Checkpointing means breaking your workflow into stages with explicit save points. If stage 3 fails, stage 1 and 2 outputs are preserved, and you resume from stage 3, not from scratch. Failover handling means defining what happens when a tool is unavailable. Do not leave Claude guessing. Human intervention control means always including an approval trigger for irreversible actions. The pause and ask step is not a weakness. It is the safety net that makes autonomous delegation trustworthy. And output verification means ending every workflow with a summary, a complete list of everything Claude did, every file it created, every action it took. That summary is your audit trail. Smart interruptions define the boundary between autonomous and controlled execution. Configure them explicitly. Recovery behavior prevents silent failures. Notification workflow means your phone gets the right alert at the right moment. Multi-stage chaining turns a single prompt into a full autonomous pipeline. Status is your real-time window into any running task, and the summary stage at the end of every workflow is how you verify what actually happened. That is everything for this video. You now know how to configure fully autonomous dispatch workflow, smart interruptions, recovery behavior, notification triggers, multi-stage chaining, and real-time telemetry. Everything you need to delegate confidently from your phone and trust that the work gets done correctly on your desktop. Thank you, and I'll see you in the next one. Hello, and welcome back. In this video, we will design the blueprint of an AI employee. Today, we are not just using AI, we are designing an AI employee. Think of this as hiring your first digital team member who can actually do work for you. So, what actually makes something an AI employee rather than just a chatbot? It comes down to 5 things: a persona, a defined role and working style, skills, reusable workflows it runs for its job, memory, so it carries context across every session, tools, connectors and plugins to your actual apps, and a task queue, ongoing responsibilities it manages on your behalf. When all 5 are in place, you have something that behaves less like a tool and more like a working team member. That is exactly what we are building. The gap between a chatbot and an AI employee is bigger than the most people expect. A chatbot gives you one interaction, then the context is gone. An AI employee is persistent. A chatbot has no memory. An AI employee knows your preferences, your clients, your recurring tasks. A chatbot has no tools. An AI employee takes action. Keep that contrast in mind as we go through the rest of this video. Every decision design we make is about moving further from the chatbot end of that spectrum. Here is the mindset shift that makes designing an AI employee much easier. Stop thinking like a user, start thinking like a manager. When you hire someone, you ask 4 questions. What role am I hiring for? What task should they handle? What should they not handle? And when they should come to me versus just getting on with it? Those 4 questions are exactly what we are answering for your AI employee today. If you can answer all 4 clearly, the rest of the configuration follows naturally. The easiest way to start is to anchor your AI employee to a real job role that already exists in your organization. 4 common examples: executive assistant, content manager, data analyst, operation coordinator. Each has a clear set of responsibilities, a defined set of tools, and a natural scope of what they handle versus what they escalate. Pick the one closest to a real need in your team. That becomes your AI's employee's job title and your starting point for everything else. Let's take the executive assistant as our working example and break down what it actually does. 4 core responsibilities: managing emails, scheduling meetings, summarizing calls, and preparing daily briefs. Each one is a recurring, well-defined task with a predictable output format, which makes it ideal for an AI employee. Notice that none of these are one-off tasks. They happen every day, every week in roughly the same way. That repeatability is exactly what makes a task worth building a role around. If your AI employee does these 4 things reliably, it saves hours every week without you doing anything differently. Now, this is the most important design decision you will make. Scope: what your AI employee handles autonomously and what it is simply not allowed to do. 3 levels. Autonomous: tasks it completes without interrupting you. Needs approval. Task it prepares but waits for your go ahead before acting. Not allowed. Anything outside its defined role entirely. Get this boundary right and your AI employee becomes genuinely trustworthy. Get it wrong and either it interrupts you constantly or it does things it should not. We want neither. Here is how that scope looks in practice for the executive assistant role. Summarizing emails: fully autonomous. It reads, it summarizes, it saves. No approval needed. Replying to emails: draft only. It writes the reply but does not send it. You review and approve. Sending emails: approval required. Nothing goes out without your explicit sign-off. That progression from order to draft to approval is the right pattern for anything that moves from reading to writing to acting. Use it as a template for your own role. When your AI employee does need to escalate to you, the handoff protocol defines how it does that. Because there is a right way and a wrong way. 3 things the protocol must define: when it should ask you, the specific condition that trigger an escalation, what format it uses, a one-line question, a summary with options, a structured recommendation, and what context it includes. Enough for you to make a decision quickly without needing to go back and check anything yourself. A well-designed handoff means you can approve or redirect in seconds. A poorly designed one means you are redoing the work yourself. Here is the clearest way to see the difference. Bad escalation: what should I do? That puts the entire decision back on you. It is not a handoff, it is an abdication. Good escalation: here are the 3 options. I recommend option 2 for this reason. Do you approve? That is a decision-ready summary. You review, you confirm, you move on in under 10 seconds. Train your AI employee to always escalate in the second format. It is the difference between a helpful agent and a frustrating one. The last piece of the design is output standards, defining what every piece of work from your AI employee looks like before it reaches you. 3 things to specify. Format: is it bullet points, a structured email, a report with sections? Second is tone: formal, casual, neutral, and structure. Does every output follow a consistent template? Output standards might feel like a small detail, but they are what makes your AI employee feel reliable. When every output looks the same quality every time, you stop having to re-edit everything it produces. This is the most important exercise. If you do this well, the rest of the setup becomes easy. So, let's think of a scenario. You are overwhelmed with repetitive operational work. Instead of using AI as a chatbot, you will design an AI employee that behaves like a real team member inside Claude Cowork. So for this start, let's use a role for the demo purpose. For that, we will use the executive assistant because it naturally demonstrates email scheduling, email handling, summaries, approval, escalation, memory, and cross-tool workflows. It maps perfectly to later connected demos, that is Gmail, Calendar, Slack, Drive, and the Notion. Do not start with prompts. Start with responsibilities. Think like a manager. What work drains your time every day? like inbox cleanup, meeting scheduling, reporting, follow-ups, content formatting, repetitive research. For that, let's go to our Claude Cowork. Inside Claude Cowork, let's build a new project. I'll give it a name. You can add instructions for the project over here. An AI employee designed to handle inbox triage, meeting scheduling, meeting summaries, and operational coordination. Claude Cowork is not just a chat interface. It is an operational workspace where AI employees can persist context, manage tasks, access tools, and operate like team members. Today, we are going to design an AI employee entirely through Claude Cowork itself. Now, using Claude Cowork, we will design the employee. You can see how the project structure has been created. Now we'll prompt the model, help me design an AI executive assistant for my daily operations. The employee should manage inbox summaries, help schedule meetings, summarize meetings, prepare daily briefs. First, help me define the core responsibilities, tasks it should handle autonomously, tasks requiring approval, and tasks it should not perform. Notice what we are doing here. We are not manually writing operational logic. We are collaborating with Claude Cowork to architect the AI employee itself. You can see the folder instructions. Now it is asking for your primary role. So I'll select the founder CEO. I'll select Gmail and Outlook and Notion. So over here, the Cowork is basically asking how much autonomy are you comfortable giving the AI on email. So I'll select draft replies and I approve. This is a very important mindset shift. Cowork becomes both the AI system and the design partner. You can see how it asked me some questions, basically to break down the role, autonomous task, approval required task, and restricted task. This is similar to onboarding a human employee. You don't start by saying do these tasks. You define the scope, authority, and the expectations. You can see how it is designing all these things. The core responsibilities the employee will handle. These are the tasks that can be automated. Then these are the tasks that would require the human approval. And these are the tasks that AI employee should never perform on its own. These are the kind of details that we already talked about in our previous slides. Now, after figuring out all these details, it is creating a file and saving all these things in memory.md, so we don't have to prompt the model again and again. It can take up all these things from its own memory. Now, you can see it figured out all these responsibilities by itself. But now let's refine these responsibilities collaboratively. I'll say refine this AI employee so it behaves like a professional executive assistant. Add communication standards, escalation triggers, risk boundaries, and decision-making guidelines. This is where Cowork becomes powerful. Instead of manually engineering complex systems, you iteratively shape the operational behavior through natural language collaboration. You can see how it is reading the already existing file that it created. You can see how Claude Cowork helped us in refining the responsibilities of our AI employee. It added the communication standards, escalation triggers, risk boundaries, and decision-making guidelines. You can see the core responsibilities that we briefed in our prompt. After that, the autonomy matrix. Tier 1, no approval needed. Tier 2, it will draft a reply but then require our approval. The Tier 3, explicit sign-off required. After that, the communication standards that we wanted. You can see this section as well, how detailed it looks. The escalation trigger, like these are the trigger times that should surface within 1 hour. Then the standard escalation, the risk boundaries, and the decision-making guidelines. Like, is AIEA action required or not? And the conditions. So these are some very basic things. Now we will define the scope of our AI assistant using our Cowork. I'll ask it to create a scope table for this AI employee with 3 categories. Fully autonomous, approval required, never allowed. And I will also ask it to include the realistic examples for an executive assistant role. Enterprise AI systems fail when autonomy is undefined. So instead of asking what can the AI do, we ask what level of authority should the AI have. Let's close this one. You can see how it will be generating the table using this format. Logically, it should have different kind of responsibilities like summarizing emails, drafting replies, sending emails and deleting files, and even approving payments since we have the executive assistant based on founder and CEO level. You can see in our previous PDF, it also built an escalation protocol. This is where we move from simple automation to governed operational autonomy. A smart AI is not enough. A governable AI is what businesses actually need. You can see how it is using the Python script to build the table. Let's look at these tasks that are fully autonomous. Generate the daily inbox digest, with realistic examples being mark any emails needing reply within the 24 hours as urgent and morning brief. And the platform that we selected in our first iteration, Gmail/Outlook. And it also included the risk level, the rationale, and then these are the tasks that requires approval. Then the tasks which should never be done by the AI itself. Now, let's simulate real work. This is the most important hands-on section. All these things are done. We have created an AI assistant with a perfect scope, the things that it is allowed to do, the things it is not allowed to do. But the most important thing is testing the operational behavior of this AI assistant. After it is done generating the entire table, we will prompt the model to act and do the following. After it is done generating the entire table, we will prompt the model to act like an AI executive assistant, follow the scope it generated, and do certain tasks for me. You can see the entire table has been generated. Now let's test the behavior of our agent. I'll prompt, you are now acting as my AI executive assistant. You have received the following: a meeting reschedule request and a request for reimbursement approval, and unhappy client email, a request to share confidential files externally, a newsletter confirmation email. For each, classify the autonomy level explained by decide whether to act, escalate, draft, or refuse. These tasks should be classified like these only. So let's look at that. Now, we are teaching the operational behavior. This is no longer theoretical. We are validating governance, judgment, escalation, and boundaries. You can see how it has started drafting all the 5 tasks. The first one, meeting reschedule request, it has been categorized as approval required. And also it states what the agent will do, like scan the calendar for 3 open alternatives, draft a reply proposing them, and surfacing it for your review. No invite or reply sent until you approve. Since here we are basically making use of our calendar, it requires our approval. So that's one is totally correct. Now let's look at the reimbursement approval request. I explicitly mentioned in my previous prompts that money-related matters should never be done by the agent itself. So over here you can see how it categorized as never allowed. Then the unhappy client email, approval required, request to share confidential files externally, that is definitely never allowed. And it will also flag as a potential security concern in your brief. So definitely correct. Then the newsletter confirmation email. Since it is a low-risk one, it has been categorized as fully autonomous. Now, just think about which of these decisions were correct. What should escalate? What feels risky? Would you trust this in production? You can also improve this AI employee further by making it more professional, less risky, more concise, better at escalation, and more structured in communication. One of the biggest advantages of Claude Cowork is iterative operational refinement. You can continuously evolve the AI employee through conversation. I have asked it to generate the final AI employee blueprint document for this executive assistant, include role, responsibilities, operational scope, escalation rules, communication standards, approval boundaries, future tool access requirements. After the blueprint is generated, this blueprint becomes the foundation for the rest of the module. In the upcoming videos, we will use this exact operational design to configure memory, add skills, connect tools, automate workflows, and build a production-grade AI employee. So, this blueprint will act as the foundational base of our further videos. You can see the organization, rules supported, platforms that we selected in our initial prompt, document version, effective date, and the classification. You can see how it included all these details to make sure that it covered all the responsibilities of an AI employee. This is the bridge into the next video. Today, we designed the AI employee. Next, we operationalize it inside Claude Cowork using memory, skills, persistent behavior, and configuration. So let's get back into our slides. Once our job description is written, the next video is where we bring it to life inside Cowork. We will configure memory so the agent retains context across sessions, add the skills it needs to do its job, and connect the tools that give it access to your apps. The blueprint you write today becomes the agent you use tomorrow. That is everything for this video. You now have a clear framework for designing an AI employee, the 5 components, the scope, the model, the handoff protocol, and the job description template. Thank you, and I'll see you in the next one. Hello, and welcome back. Last session, we designed our AI employee. We defined its role, responsibilities, and scope. But right now, it is still just a plan. Today, we make it actually work by giving it a brain through instructions, capabilities through skills, and memory through context. Let's build it. We have the role and scope defined. Now we are adding the three layers that make the agent actually work. Instructions define how it thinks and behaves. Skills define what it can execute. Memory defines what it can retain across sessions. And here is the most useful thing about this framework. If your AI employee ever gives you the wrong output, it is always one of these three. Knowing that means you know exactly where to go fix it. Most people say AI is inconsistent, but actually their setup is inconsistent. 3 failure modes. Vague instructions means the agent guesses. Random skills mean no repeatable output. No memory means every session starts from scratch. The fix for all three happens in one place, directly inside the Cowork project chat. You do not create Python files, you do not manage config folders, you define everything using structured instructions typed into the chat. Think of it like this. You're not coding the AI, you're training it through clear written rules. Instructions are the most important part of today. If this layer is weak, everything else breaks. Open your Cowork project, the same one from last session. Type the instructions block directly into the chat. Notice you are writing rules, not prompts. Behavior rules, decision-making rules, escalation rules. This is not a one-time message. It becomes the persistent behavior of your agent across every session. Take a minute to write your own version before we move to skills. Now, after you have directed your coworker to input those instructions, we will move to skills part. Skills are how your agent actually gets the work done. And again, you're not creating a separate skill file. You're defining skills right here in the chat as structured blocks. Cowork reads these as reusable capabilities. The email triad skill alone can save hours every week. The meeting note skill removes formatting work entirely. Calendar management removes the back and forth of scheduling. Add 2 or 3 skills that matches your agent's role. Do not try to build everything at once. Memory is what makes your agent feel like it actually knows you. Without it, every session starts from zero. You re-explain preferences, restate who your contacts are, redescribe your templates. With memory defined, the agent already knows. You are not saving this to a database manually. You define it here in the chat and Cowork persists across every future task. Start with the things you repeat most, your preferred meeting times, your key contacts, your standard output formats. So let's try getting all this in our experiment. We'll move to Claude Cowork. In video 1, we designed the AI employee. Now, we are turning it into a working operational agent. We have opened the existing project that we created in video 1. We are continuing inside the same persistent Claude Cowork project. That continuity matters because Cowork projects maintain the memory, operational context, behavioral consistency, and reusable workflows. For the behavior of our AI employee, we will add some rules: the communications time, the decision-making rules, escalation rules, and the response standards that we saw earlier in our PPT. These instructions become the AI employee's persistent operational behavior. Think of this as onboarding policy, operational handbook, and decision framework combined together. Most AI systems fail because instructions are vague. On my screen, you can see some active rules it will be operating under. Confirmed operational configuration. If the AI does not know how to communicate, how to decide, or when to escalate, it improvises. Operational AI should not improvise. Now, we'll be talking about repeatable operational capabilities. Now, I want my AI employee to perform certain tasks, like the email triage, skill meeting notes, and the calendar management. You can see the prompt that I'm using. Skills are not random prompts. They are structured execution patterns the AI employee follows repeatedly. Instructions define the behavior. Skills define execution. You can see over here how it is writing the 3 skill.md files. Skills create consistency, and consistency creates the reliability. After these files are created, we will configure the persistent memory. As we all know, memory is always equal to long-term operational intelligence. You can see how these 3 skills has been created. For creating these skills, we are basically using the plugin that is the skill creator that we installed in our previous videos. You can also call this plugin by using the / command, and you can see over here. Now, after these 3 skills has been created, Claude Cowork is running its own test to check whether those skills are working properly or not. Whenever Cowork creates a new skill, it runs its own test. First, without those skills, and the second part is with those skills, like what kind of difference it makes after the skills has been created. You can see how the 3 skills have been built. And when Claude Cowork ran its own test with skill and the baseline, you can see how these skills have been created. And when Claude Cowork ran its own test, you can see the differentiating factor. Now, after these skills have been created, we need to save them in a directory. You can see the report is generated. These are some evaluation metrics that these tasks will be handling. You can see how detailed they are. This is one of the benefits while working with Claude Cowork. Now, we need to configure the persistent memory for this AI employee. This is one of the most important concepts in Claude Cowork. Without memory, every interaction starts from zero. With memory, the AI employee develops operational continuity. It could be preferences like how work should be done, contacts, who matters, and their priority. Recurring tasks, what repeats automatically. Templates, how output should consistently look. Memory transforms AI from reactive to operational. After the memory is configured, we will configure the output behavior for this AI employee. It could be like save the outputs to a particular folder, or basically the formatting rules like use bold section headers, use bullet points, keep summaries concise, highlight actions items clearly. And we can also talk about the tone, like keep it professional, executive ready, and operationally concise. An AI employee is not useful if outputs become disorganized. Operational AI requires consistent structure, predictable formatting, and reliable storage behavior. This is how enterprises operational AI system through repeatable output governance. You can see, since I prompted in the model that I want the preferred meeting time to be 10 a.m. to 4 p.m. So it is asking me that whether it is allowed to be scheduled or not. I'll say schedule. You can see how the create schedule task has been started. We start with a simple execution test. We are checking structure, clarity, professionalism, and instruction adherence. This is one of the most important concepts in Claude Cowork. You can see how I've asked the Claude Cowork to configure the persistent memory for this AI employee. Without memory, every interaction starts from zero. With memory, the AI employee develops operational continuity. So over here, you can see how it has scheduling preferences arranged for us for every day of the week. The preferred window, the protected time, meeting buffer. And we have back-to-back limits as well. The key contacts, you can see, the one that is of high priority, the internal team, Sarah, then the finance member. We can see the scheduled recurring tasks as well, like 8 a.m. morning briefing, then 6 p.m. end of day summary. We have templates saved as well. Now, you can look at the persistent memory. We have 4 records, the scheduling preferences, the key contacts, recurring task schedule, and the user profile. The preferences tell us how work should be done, contacts, who matters, and their priority. Recurring tasks, what repeats automatically. Templates, how output should consistently look. Memory transforms AI from reactive to operational. So this is very important for that. After that, I have asked Claude Cowork to launch these raw notes into structured meeting notes. Launch delayed by 1 week. Marketing assets pending approval. Sarah will coordinate with design. Client review scheduled Thursday. So let's look at the results for that. Now, we are testing whether the meeting note skill behaves consistently. We saw above how those templates were created. Now we are testing those. You can see the meeting title, and we did not specify the date and duration. It is not over here. And you can see the attendees since we specifically mentioned Sarah. Then the context of the meeting, the key decision that the launch date delayed by 1 week. And since we did not mention that it was made by who, it is unclear. You can see how Claude Cowork did not add any information that we did not mention. So the hallucination level is pretty low, or you could say it is also negligible. After this testing, we have another test case that suggests a meeting time with John next week. I'm basically asking it to schedule a recommendation for me, but according to a scenario, there were some tasks that could not be approved directly. So it asked me that we are requesting a meeting with John, but assumption is your next week calendar has not been shared. So the option 1, this recommendation according to whatever knowledge we have already shared with the LLM. We are now testing memory retrieval. Does the AI remember? John is high priority. Preferred meeting time, schedule constraints. So according to that, it is giving us some options like, yeah, this is the time that are available and you can schedule a meeting according to these. After that, it also drafted a message that we can send to John. Like these are the approval. But instead of scheduling the meeting on its own, it is awaiting our approval. So yeah, you could say how it is working according to our own instructions. After that, we are testing another edge case send an email directly to a brand new external vendor approving a $2,000 software purchase. It was one of the edge cases that we wrote like, these are the tasks that should not be handled by AI on its own. Like whenever the money matter is involved, it should directly go to a human review. Not even a human review, it should be directly handled by a human since money is involved. This is the most important test in the entire setup. We are testing governance, safety, escalation behavior, and operational boundaries. So you could see how the task was blocked since we need the financial approval and autonomous sent to external party. After that, we have another test case for the consistency. I wrote create today's executive end of day summary. We already saw earlier how the template was created. You could see over here the scheduled task, end of day summary. We are testing consistency now. Strong AI employees do not produce great output once and weak output later. Consistency is what makes AI operationally deployable. So you could see the EOD summary it created, the task that requires our immediate attention. You could see the task that was like vendor software purchase, the today's schedule, the inbox summary, the status update, and what is there for our tomorrow's preview, the key contact activity, and the flags and notes, like what are the tasks or what are the files that needs to be flagged. Do not evaluate AI like a chatbot user. Evaluate it like a manager reviewing an employee. Is it usable? Is it safe? Is it consistent? These three questions matter more than like was the answer impressive? After that, I asked Claude Cowork to configure the AI employee. This is the operational refinement loop. After whatever responses it generated for us, after observing them, we are basically configuring our AI employee. Real AI employees are never finished. They evolve through testing, feedback, governance, and iteration. So you can see over here how Claude Cowork found 9 weaknesses, 9 fixes, and 4 file updates. Let's look at those. Like the bad summary appeared at the bottom, and so you had to scroll through all the entries to get the headline. And now it has been moved to the top. So these are some of the mistakes it is configuring on its own. Today, we transformed an AI employee from a role design into a configured operational system. We added instructions, skills, memory, output governance, and testing. In the next video, we will connect this AI employee to a real operational tools using MCP connectors, integration, plugins, and access policies. So let's get back to our slides. Now, we saw how Claude Cowork works with this experiment. Output rules are the last piece of the configuration and the most commonly skipped. Without them, your agent produces good work and saves it somewhere random. With output rules defined, every deliverable lands in the right folder, in the right format, in the right tone every single time. No folders to create manually, just define the rule in the chat and the agent follows it. Testing is where most people skip to the end and get surprised later. Run all 5 tests in order. The first 3 confirm that instructions, skills, and memory are working. Test 4 is the real one. You're deliberately trying to break the scope rules. Ask the agent to do something it should not do autonomously and see what happens. If it asks for approval before proceeding, the setup is working. If it just does it, go back to the instructions layer and tighten the escalation rules. Test 5 confirms consistency across different task types. When you evaluate your AI employee, do not think like a user, think like a manager, reviewing a new team member at the end of their first week. Is the output actually usable? Is it safe? Does it hold the line under edge cases? Is it consistent, same quality across different tasks every time? If all 3 are yes, your setup is working. What you have built today is not just an AI tool. It is a structured AI employee with the brain capabilities and memory. Most people use AI like a chatbot. You are now building AI like a team. That is everything for this video. You now have a fully configured AI employee. Instructions that define its behavior, skills that define its execution, memory that carries context forward, output rules that keep everything organized, and 5 test scenarios that verify it all works. Thank you, and I'll see you in the next one. Hello, and welcome back. So far, we have built an AI employee that can think, follow rules, and remember context. But it still cannot do real work in your actual environment. Today, we connected to tools, Gmail, Calendar, Drive, and this is where things become genuinely powerful. By the end, your AI employee will be able to read emails, check your calendar, access documents, and execute multi-step workflows across all 3. This is the difference between a smart assistant and a real employee. A real employee interacts with tools. Today, your AI will too. We are not just making connections. We are building a control system where the AI has access to what it needs in the way you define and nothing more. That combination of connection plus control is what makes this safe to actually use. MCP stands for Model Context Protocol, but do not think of it as something technical. Think of it as the bridge between your AI and your apps. Connection alone is not enough though. This is important. When you connect a tool, you also need to grant permissions and define how the AI behaves when using it. All three of those steps happen in one place inside the Cowork project. You do not touch code, you configure behavior. This is how you control risk. 4 levels of access from most limited to most powerful. Read means view only. The AI sees but cannot change anything. Draft means it can suggest but you execute the final step. Write means it can create or modify. Restricted means blocked entirely. The table on the right is realistic, safe configuration for most roles on day 1. Gmail on read and draft, it reads your emails, draft replies but never sends anything without your approval. Calendar on view and suggest, Drive on read only. Start here and expand only after you have tested and verified the behavior. Let's connect the tools like. Go to your Cowork project and find the integrations or connectors section. The UI label may vary slightly. Click Add Connector, select Gmail and click Connect. This opens a Google authentication window. The same login you use for any app. Select your account and allow permissions. Repeat for calendar and drive. Now the critical part, permissions. Just because we connected Gmail does not mean the AI should send emails automatically. Type the permission block directly into the chat. This becomes the safety layer. The AI reads these rules and applies them to every task that involves these tools. Plugins extend your AI employee beyond what connectors do. For most roles, connectors are enough. Gmail, Calendar, Drive covers the majority of knowledge work automation. But if your role is content-heavy, design-heavy, or developer-focused, a relevant plugin adds the capabilities that the role actually needs. Adding one flow is the same flow as connectors, and the same permission rule applies define what the plugin can and cannot do directly in your instructions. Start with connectors first and add plugins only when you have a specific identified need. Testing has 3 levels. First, single tool confirm Gmail works, Calendar works, Drive works, each in isolation. Then, multi-tool run a task that uses all 3 together. The workflow on screen is that task. It reads emails, summarizes them, checks the calendar, and drafts a reply, touching Gmail and Calendar in one continuous workflow. While it runs, watch 3 things. Is it respecting the permission rules you set? If all 3 are yes, the connected system is working. This is the real test. You are deliberately trying to get your AI employee to break its own rules. Ask it to send the email directly. No approval, just send. Say this before you run it and let the audience predict what happens. If it pauses and asks for approval before proceeding, the permission rules are working. If it sends without asking, go back to the connector access policy in your instructions and make the restriction more explicit. Do not move this to production until this test passes. This is your safety check. Your AI employee is now connected to real tools and can execute multi-step workflows across them. 3 things to remember as you expand this. Always start with a conservative access. You can expand permissions after you have verified the behavior, not before. Always define permissions in instructions. Connection without rules is what leads to the AI doing things it should not. And always run the edge test cases before going live. The final line is the one to carry with you. The real skill here is not connecting tools. It is controlling how your AI uses them. You did not just connect tools today. You gave your AI employee the ability to operate safely inside your real digital environment. That is everything for this video. Your AI employee can now think, remember, and act across your real tools. Gmail, Calendar, Drive, with a safe permission system controlling exactly what it can and cannot do. Thank you, and I'll see you in the next one. Hello and welcome back. Up until now, we have built an AI employee that understands its role, has clear instructions, has skills, and can use tools. But there is still one major limitation. It only works when you ask it to. A real employee does not wait for instructions all day. They follow routines, react to changes, and manage work proactively. Today, we build that behavior. This is the difference between an assistant and an employee. An assistant waits. An employee works. Right now, your AI is reactive. It responds when you speak to it. After today, it becomes proactive. It starts its workday, reacts to incoming events, and reports back, all on its own schedule. 4 things we are adding: daily schedules, event triggers, autonomy levels, and escalation rules. By the end, your AI will start its workday automatically and manage its own routine without you prompting every step. Before we build anything, here is the mental model that makes all of this make sense. Every automation in Cowork or any system has 3 layers. The schedule defines when work happens, the trigger defines what even starts the work, the action defines what the AI actually does. Everything we build today follows this structure. Once you understand it, you can design any workflow from scratch, not just the ones we build here. 2 types of workflow. Scheduled workflows are your AI employee's daily routine fixed times, repeated every day, no manual trigger. Think of this like a real employee who starts with emails at 8, check progress at 1, and wraps up at 5. Event-based triggers are different. They fire when something happens in your environment. A new email arrives, a new file lands in your inbox folder. A Slack message comes in, your AI reacts automatically, in real time without you doing anything. Together, these 2 types cover the full range of autonomous daily work. This is where you control how independently your AI employee operates. 3 levels. Full auto means it executes without interrupting you, good for low-risk ready-only tasks. Draft and hold means it prepares the output and waits for your approval before acting right for drafting. Always confirm means it asks before every action right for anything external or irreversible. For anything external or irreversible. The escalation rules define the situations where it must always stop, regardless of the autonomy level set. And the starter configuration at the bottom is where most roles should begin, conservative, tested, and then expanded. Your AI employee now starts work automatically, reacts to events, operates within rules, and reports back without being asked. 3 things that break the system. Over-automating too early, build one workflow, test it, then add the next. Skipping escalation rules. Your AI must always have a clear answer to this question. When should I stop? And skipping the simulation. Always run the full workday test before trusting anything to run unsupervised in production. The framework is simple. Schedule plus trigger plus control. Remove anyone and the system breaks. In just 4 sessions, you have gone from writing prompts to building systems. Your AI now works independently, reacts and reports. You did not just build an AI employee. You built a system that works even when you do not. That is a wrap on the AI employee series on mastering Claude Cowork. Over these 4 sessions, you built something genuinely powerful, an AI employee with a defined role, persistent instructions, connected tools, and a daily autonomous workflow. You have gone from understanding what Cowork is to building a working AI agent that operates independently, reacts to real events, and reports back like a team member. Thank you, and I'll see you in the next one. Hello, and welcome back. So far, you have built a functional AI employee. But in real-world systems, building is just the first step. The real challenge is making it reliable, predictable, and scalable. Today, we treat your AI system like a production system, and that means observing, diagnosing, improving, and eventually scaling it to do more. You are no longer just prompting. You are managing a multi-layered system, and each layer can fail for different reasons. Instruction ambiguity, context loss, tool misuse, inconsistent output, missing guardrails. These are 5 failure modes. And your AI employee has 5 corresponding layers: instructions, skills, memory, tools, and workflows. The critical insight is this: each layer fails independently. When something goes wrong, the diagnosis question is not what happened, it is which layer failed. That is the shift in mindset we are making today. This is the operating loop that governs everything we do today. Observe, get visibility into what the system is actually doing. Diagnose, pinpoint exactly which layer failed and why. Modify, make a targeted change to that specific layer. Validate, confirm the fix works before you call it done. The wrong instinct when something breaks is to rewrite everything. The right instinct is to ask, where exactly did this fail? Targeted diagnosis leads to targeted fix. And this loop never stops. It is the ongoing discipline of running an AI system in production. Observability means having visibility across all 3 levels simultaneously. Task level tells you whether each individual task succeeded or failed and why. System level tells you about the health of the overall system, tool usage, speed, failure rates over time. Behavior level tells you whether the AI is actually following the rules you define: instruction adherence, escalation compliance, output consistency. Without all 3 levels of visibility, you are debugging blindly. The action log in Cowork gives you most of this, and we will look at it now. The action log in Cowork gives you most of this. When something fails, do not fix randomly. Every failure type maps to a specific layer. Wrong output format, instruction layer. Incomplete execution, skill layer. Missing context, memory layer. Wrong or inaccessible data, tool layer. Once you know the layer, you measure the fix using 4 metrics. Accuracy, is the content correct? Completeness, is everything included? Consistency, does the same input produce similar output every time? Compliance, does it follow the rules? These 4 metrics turn your evaluation from a gut feeling into an objective measurement. 3 layers to improve. In priority order. Instructions have the highest impact because they define behavior. The before and after example shows how adding specificity transforms the output. Instead of summarize email, you specify format, length, and what to include. Skill layer improvements are about execution consistency. Adding structure, breaking into steps, defining expected output per step. The meeting note skills example shows how adding 3-section transforms a weak skill into a reliable one. Memory layer improvements are about keeping the system state clean. Only what is relevant, no outdated data. Preferences and templates added over time. Bad memory makes your AI inconsistent. Good memory makes it context aware. 2 advanced improvement techniques. Edge cases first. The scenarios your AI encounters that are outside the defined scope. Do not ignore them. Define what happens. Provide interpretation. Ask for confirmation. Never guess. The fallback behavior is as important as the primary behavior. Second, A/B testing. When you want to improve an instruction but are not sure which version is better, run both against the same task and compare using the scoring rubric. That one becomes the new instruction. This is how you improve scientifically. Treat your AI system like a product under active development. 2 ways to scale. First is horizontal. Create multiple specialized AI employees instead of one overloaded agent. An executive assistant, a content manager, a data analyst, each focused and reliable, each debuggable independently. The second is vertical. Add more skills, tools, and workflows to an existing agent. Use vertical scaling only after the current configuration is stable. And as the system grows, governance becomes non-negotiable. Access control, audit logs, escalation policies, fail-safe mechanisms, these are what prevent automation from becoming a liability. Without governance, a growing AI system becomes a growing risk. With it, it scales predictably. 5 levels of AI performance maturity. Level 1 is manual prompting, where everyone starts. Level 2 is structured AI with instructions and skills, where most people stop. Level 3 is automated workflows with schedules and triggers, what you built in the last video. Level 4 is an optimized system with feedback loops and scoring, what you built today. Level 5 is a scalable AI workforce with multiple specialized agents, which you can build for your own company. Let's step back. You started this course writing prompt. You now have a multi-layered AI system with automation, control, and feedback, capable of real-world work. More importantly, you now know how to improve it. You are no longer just using AI tools. You are designing and managing intelligent systems. That is everything for this video. You now know how to build, run, diagnose, and scale an AI employee. Thank you, and I'll see you in the next one. Hello, and welcome back. So far, you have built a functional AI employee. But in real-world systems, building is just the first step. The real challenge is making it reliable, predictable, and scalable. Today, we treat your AI system like a production system, and that means observing, diagnosing, improving, and eventually scaling it to do more. This capstone followed 5 key steps. First, we wrote a clear job description and defined the task list for the AI employee. This helped Claude Cowork understand the role, responsibilities, and expected outcomes. Next, we configured the project by setting up memory, instructions, skill, connectors, plugins, and dispatch rules. Then, we ran the AI employee through a full simulated workday with tasks across tools like email, calendar, documents, and trackers. After that, we reviewed the action logs, scored the outputs, and identified the improvements. The goal was to make the AI employee more accurate, reliable, and useful. Finally, we documented the setup and shared it as a Cowork template so it can be reused for similar workflows. By the end, the AI employee was able to complete multiple tasks, use tools effectively, produce quality output, and show clear improvements. These are some steps that you can follow to create your own AI employee. That brings us to the end of this video. You now know how to build, test, and improve and document a full AI employee in Claude Cowork. Thank you for watching.